Very good afternoon and salam sejahtera. Welcome to this very special session arranged for UM under the topic of Wolfram Mathematica meets IR 4.0, better known as Industrial Revolution 4.0, and LLM, Large Language Model. For those who attended yesterday, the very first session from 3 to 5, we have shared with those attendees who came from University Malaya about a basic introduction to Wolfram Mathematica. So based on the last survey, we saw that about 2/3 of you are fairly new to this Wolfram language. Wolfram has been around in the market for more than nearly 40 years and is a very established, robust, advanced computational package. So when I say robust, advanced computational package, it means that it's a general language for advanced computation. Now, unlike Python, Wolfram language is proprietary software. So it has a lot of functions, more than 6,000 functions carefully designed and caters for people coming to field for engineering, mathematics, applied science, statistics, and business, econ, and so on and so forth. Now, of course, Python is one of the very popular and important open source programming language out there. So if you are actually Python users, good for you. You can carry on with whatever projects you have. And if you look for something more specific, then with functions that carefully and professionally design and cater for specific use, with a little bit of coding, that Wolfram is something that worth your attentions. Because Wolfram is a very high-level programming language, or rather we say coding. This day, the development in market is more and more packages and especially coding packages out there, especially this proprietary software, they are heading to a direction is something called no coding. Of course, that we as programmers and coders, we still want to have certain controls. So advanced computation package Wolfram will give you a two-way out. Either you want to go into a traditional way or having a lot of controls and details, how you want a solution to perform. This Wolfram language is one of very good choices out there for engineering, mathematics, and applied science and scientists, so on and so forth. And if you say, hey, I have actually specialists in some of my very unique domain, and you are not actually trained as programmers, and you just want it to be automated, you want it to be actually turned into a solution that could be deployed, and Wolfram offer you another way out, which is we call it automations. Yeah, there's a lot of automated coding and automated algorithms built in Wolfram. And especially now it becomes very popular and useful, especially coming under the context of industrial revolution 4.0. As we know it, when ChatGPT was launched sometime last November, our world, not last November, the November before last, that means year 2022, and the world's been turned upside down since then in the past 14, 15 months. And generative AI become part of our daily life. So when generative AI becomes something that productivity tool we have been using on a daily basis, we are looking at things is more and more automations. So I've been in the industry for about nearly 26, 27 years. And since day one, I've been asked, hey, in order to streamline our productivities in our production force and any operation management, is there a way we can automate it? Is there a way we can optimize it? When we try to automate the process along the way, we're talking about time saving and money saving, cost cutting. So this is idea. So today, when we are sharing with you Wolfram language, after all, we want to keep ourselves up to date with the today modern world. When people are having less and less patience about time, as well as the cost incur, when it comes to something that actually that help our life to become better in productivities and efficiency. Now, before I get started with Wolfram language, once again, my name is Peter Lim. I'm senior consultant and also trainer for Wolfram language in the past 20 over years. And today I'm here to share with you not just Wolfram language perspective, but I'll share with you because majority of you, two-thirds of you are actually new to Wolfram language. Like I say, either you're a Python user, you're R users, or whatsoever actually other packages, you are in the fields of research and development and academic. So I'd rather share with you what's happening out there in the first 20 minutes so we have better ideas and agreement why we are going to share what we're going to share later with you. How is it relevant to you? Because what I'm sharing is from my perspective and experience. You say, hey, Peter, what's going to relate to me? Why should I spend next 2.5 hours with you? Now, that's what I'm going to share with you in the current environment we are in. Now, after that, I'll share with you some of the technologies we have been working on. How could it be actually part of the add-on advantage you as University Malaya, fellow students or lecturers or researchers? Yeah, because as Desmond emphasized yesterday, Wolfram language is available for everyone in University Malaya, no matter which campus you're at. Either you're on-site or off-site, as long as you have a valid email, you're entitled to one free copy. Either you can run it physically on your computer or you can run it from a cloud, depending actually your preference is. So today I will share with you these important 6 different things happening out around our current world right now. So some of the information might not be up to date, but it's actually worth our attention because some of the information I got about 6 months ago, I haven't really updated everything, but things actually more or less same. Yeah, more or less, and it's getting more instead of less, in fact. Now, as we know that actually Miasat satellite systems then actually is Malaysia own our own satellites for telecommunications since about 2 decades ago. And now, little known to many people, including Malaysians, right? We have actually launched more than about 11 or a dozen satellites in the past 2 decades. Satellite have lifespan. Yeah, you launch it, you will not expect to be in orbit forever. After maybe the 12, 20 years, it become one of the space rubbish. Yeah. So now, in fact, we have about 4 or 5 active satellites out there. And what actually caught the attention in Malaysia was the year 2022. That was like nearly about 1.5 or 2 years ago. And we launched a Miasat 3D satellite. That was actually a lot of it was very promising. Yes, it's working. It's supposed to work because that with the launch of this Miasat 3D satellite is I don't remember either this is number 12 or 13 satellite we are launching at this South America. I think the place called Guyana Space Center, if I remember correctly. It costs about 1.2 billion. It's not cheap. It's not cheap. But the things that return is it's supposed to work for about over a span of 18 years. And it was promised as one of the added new channel for telecommunications in the rural area like Sabah and Sarawak. And so that people have more satellite actually access also that this multimedia access as what is promised and it's supposed to be like that. And we know Malaysia is very excited with that because we are launching one satellite, right? It seems to be able to benefit a lot of rural areas in Malaysia. And also it claim, government claim, it also will become one of the add-on telecommunications community to a nearby three countries. So we want satellite actually benefit that much. But many people do not know. Now, if you look up a night sky in certain place in the world, in Malaysia, I try to look up night sky. I've never seen it, but you could see that this actually video footage was captured by a lot of people throughout the world in different actually areas. And you look at that, it's not UFO. It's a trained satellite. A trained satellite by whom? By SpaceX. Now, we know as about, if I look back at statistics, I still remember year 2021 when I was looking at these developments, telecommunication in Malaysia, throughout the world, right? During that time, about 3 years ago, right? In the orbit, right? Throughout the world, either it's like those satellites known to people, maybe they are so-called spy satellites unknown to us, but those actually either commercially or privately owned or owned by government is nearly about less than 5,000 satellite out there in year 2021. But we know even by year 2021, 3 years ago, half the satellite was owned by SpaceX. That was crazy. You say, hey, less than 5,000 satellites out there in our orbit of Earth, half of them is owned by a private company, SpaceX. But SpaceX did not stop there. We know it's keep on launching satellites in a very intensive manner. In the past 2 years, almost sometime in a weekly basic. And even the government, the US has approved that they're going to launch that. US actually not just approved this year, they approved it 2 years ago. They approved a SpaceX that going to launch actually satellites, 30,000 satellites out there. So final goal could be 40,000. Now we start asking ourselves. Now, if you look at this day, SpaceX already own more than 5,000 satellites. Now, up to date now, about 5,000, 6,000 satellites. If one satellite, it can do that much a so-called improvement in telecommunication, I'm not sure. Yeah, even though SpaceX claim that, it's going to improve the internet coverage and communication throughout all angles in the world. But imagine the world actually filled with actually 40,000 satellites. Now, I'm not here to talk about any conspiracy theory. It's interesting topic to talk about, isn't it? But I'm here to talk about our world is full of coverage of data. Communication data, those things are not shut off. The second thing is like talk about distance. If you look at this footage that was released about 3 years ago, and 3 years ago, you will see this little actually seems like a drone flying. It's not somewhere in a desert. It's a flying millions miles away from Earth. That's the first time human being ever fly a machine outside planet Earth. That footage was captured in the surface of Mars. And that was on April 19, 2021. It was only hovering about 10 feet for 40 seconds. This project by NASA, they only intended to fly. This can lift off and came down. It was considered successful. And NASA wanted it maybe just like to see this little drone can fly a couple of times. Considered very successful already. But you have to imagine, in order to control something remotely, as far as a few millions miles away from Earth, it takes about 5 to even 20 minutes, depending the angles of Earth and between Earth and Mars. Now, you have to imagine, flying something on Mars, right? Now we know it's the atmosphere on Mars, but the atmosphere on Mars is only 1% density compared to the atmosphere in Earth. So you want to propel something, fly like helicopter, and in Mars is a very challenging way. And also we have know that the gravitational force of Mars is about 1/3 of Earth. So there's a lot unknown and also the unpredictable environments on Mars. So you want to fly something like that, right? This is something that amazing. But then now, we're not just actually having a huge coverage on Earth. We're having this distance remote autonomous actually flying machines on Mars. And it was so successful, just up to last week, this flying drone called Ingenuity just retired. it was supposed to take off a few times, but it went on the missions for nearly about 2 years. And it's just last week I saw the news. It finally stopped. But the last collected information I had, that was in sometime about 6 months ago. By that time, he already achieved more than 50 to 60 flights. So this is something amazing. So human being now, we are surrounded with connectivities, and also we can actually remotely controls something few thousand kilometers and to up to like 10 or millions kilometers, that from as far as between Mars and Earth. So distance and connectivity is no longer an issue. Now, the third development like I talk about, what's happening right now in the environment is about the power of the AI and the accuracy that AI is going to help us. Now, if you look back to 1997, there are two defining moments, I think, in my opinion. Now, in 1997, IBM Deep Blue came out with one supercomputer that, if for the very first time in human history, that machine beat a world champion in chess. Now, in that time, this AI wasn't part of the pictures. That the reason actually this Deep Blue by IBM able to beat the world champion is because we have a breakthrough of computing power. Yeah. So in this particular case, the IBM managed to in the memory in the entire the hardware structures coded in all the strategies that that can be coded in the memory. That they coded about nearly about 700,000 grandmaster games. That means that there's 700,000 that's different strategies. And the thing is, the computer developed by IBM able to calculate nearly about 100 to 200 million position per second. So looking at all the calculated risk and gain, right? The system able to beat a human being for the first time, but nothing to do with AI. Only until year 2015, nearly about 18 years later, and that time, Google developed something called AlphaGo. AlphaGo, this is the very first time that Google, under this development research arm called DeepMind, they proved that using a new AI algorithm called reinforcement learning, and machines able to learn from the error and make corrections on own. That means that we do no longer have to, in a traditional way like 1950, 1960, when machine learning first came to research and developments, even come to application, we have to tell the system what is right or wrong, and what is up or down, what's black or white. But using reinforcement learning, the system able to learn based on the gain and the punishment. They're going to figure out what's the optimized way to counteract and make decisions accordingly. So, and also for a very first time, and using AI technology called reinforcement learning, one of the very important algorithms, in year 2015, the world champions of this Go chess was beaten. Now, this is something that opened up a new era. So you could see ever since then, these so-called these developments R&D arm of DeepMind did not stop there. they use an old classical computer games called Atari. They introduce in this reinforcement learning algorithm to see that whether actually without properly code the behaviors and properly tell any system what to do, can it, using the same algorithm called reinforcement learning, able to learn how to play a game? Not just play a game, but play it effectively, even play it like the magic. So you could see here in this particular case, right, this one of the very favorite games in the 1970s by Atari. And it only shortly like 2 hours of training by reinforcement learning algorithm. It started playing like expert. It makes scary, but what actually is more scary is with a simple algorithm these days. Now, the algorithms of a lot of machine learning and when people first started developing that ever since 1950s and 60s, then now there are more and more algorithms being introduced to the market. But now we see that nearly about 4 hours training the system play not just like as, but the system play actually, if it figured out how to hack the system in a way. So you could see that, but it by bouncing back the ball, the bar down there did not do anything at all. It let the ball actually bounce up from behind, destroy the whole obstacle by its own. So we could see that actually right now, AI becomes something that very prevalent. And of course, little known to many of us. In fact, fuzzy logic, of course, there's some argument. Is fuzzy logic part of the actually classical AI or not? But as many of us, we do agree, yes, fuzzy logic in a way is part of AI. It's been introduced to our household appliances ever since the 1980s. That now almost the appliances like household appliances, we cannot live without actually fuzzy logic already. For example, you put in your dirty laundry. How could you know automatically to decide how much water to fill up? What's the level of spin is a spin order in order to make sure your laundry is clean and dry, and also without destroying your delicate clothing. Things like that actually AI become part of daily life here and there. But of course, in the past few years, with the introduction of deep learning, which I'm going to show to you in the third part of the Wolfram language later on, and we are actually migrating very quickly to what is so-called machine learning, to something that deep learning is able to handle unstructured data. For instance, data that in the past we deal with categorical data, we deal with numerical data, but how about audio visual? Those data are not something that you could actually easily code with. And so deep learning came to rescue. So with all those unstructured data, in fact, the video I put down here is using surveillance cameras to try to actually detect the wildlife like elephants in Africa. This is not something new. I already saw that as early as 4 or 5 years ago. And some of our commercial entities in Malaysia, yes, you heard me right, in Malaysia, they'll be using drone, actually putting in this deep learning and try to actually detect the agriculturals and control and monitors like the farming estate of palm oils and our herb. So those things is all no longer actually new. So now, if you look at here, AIs have been changing our world. And also look at this little video clip. These smart automations already started year 2022 in Beijing. I did not keep track right now what's happening in Beijing right now. But what happened 2 years ago? That's almost like 2 years ago. This was like April 2022. Now, we know that even like Tesla car, right? In many countries, they still have a law to govern that you, as smart as the car seems to be, the car cannot drive without a passengers or driver behind the wheel. You need someone, a co-pilot, a pilot behind the wheel in order to go on road. But that was 2 years ago. Beijing's already approved one of the companies in Beijing's, right, to ferry passengers without actually any driver behind. This is already happening. And because the reason they can allow to do this, right, we know it has a lot of legal implication. Unless you have so much confidence, there's no way that you need any intervention by human being, then only can put in a full automation like that. Now, of course, automation like that in the production world, factories and logistics and warehouse is no longer new. It's already happening throughout the world, including Malaysia. And I also seen some so-called light out factory. That means they can turn off the light. Everything's running like black boxes, everything by auto machines that taking material from one place to another, put machine and come out with finished product. It's already happening. So now I'll talk about 4 things already. The coverage of data, and I'm talking about the distance actually, how far it can go, all the way to Mars. The accuracy and the autonomous decision can make my informed decision, make my AI technology. Automation, the smart automation. And finally, we look at the speed, right? And just like the government already announced, I think they already achieved lah. So like that goal is, we know a government have actually announced that you say all the populated city in Malaysia by the year 2023, and according to Digital National Berhad, they want to cover at least 80% with 5G in Malaysia, those populated areas. We are not talking about somewhere in rural. We know in early last year, where some of us actually have faced some difficulty switching between 4G LTE to 5G, and you see a lot of new transmitter coming up here and there. It's like the place that Daman I live in. So in the process, translations are hiccup happening, but that is necessary. If even right now with the old 3G mobile phone, you're not able to connect network already. But we see actually the speed it take a tremendous jump. In the past, I still remember 3 years ago, my mobile phone, the best I can go up to 5 Mbps. Right now, it can easily go at 80 to 90 Mbps with 5G and my mobile phone turned on. But theoretically speaking, why people need to go 5G? Because, like I say, the longer the distance is, sometimes the latency could be very long. Now, if you want to do something that very precise control robot, something like flying drone, you have a strategy positions or doing some very mission critical tasks, right? You cannot have the latency like in terms of seconds. That means I push button here, I want to happen immediately. 5G talking about latency less than 1 millisecond. Yeah, compared to the latency of 4G is about 50 seconds. So you're talking about 50 times faster in terms of latency. But important thing, right? In the 5G technologies, right, then you're talking about you can go up 100 times more than what you had in 4G. So in terms of speed, in terms of latency, also in terms of population, 5G can control. Theoretically speaking, compared to a Wi-Fi system, a single 5G transmitter can control up to 1 million devices. So you're talking about in terms of intensity, in terms of volume. Then we are talking about the speed and intensity. There's something that's happening actually in a very scary way. So now I'm going to share with you before later I'll go take a short break. Then I'm going to Wolfram technology. How this Wolfram technology can help us actually blend into these new developments and coverage. Yeah, intensive coverage. Yeah, extreme distance. Yeah, high accuracy and informed decision making, smart automation. Also in terms of high speed and also the intensities, how much it can cover in volume. Now, I'm going to showcase this thing. I believe many of you, if you are interested in the development technology out there, especially smart technology, this is not something that you have not seen before. But I'm going to show this thing only 3 minutes. Yeah, I really like to show this thing to a lot of time. I never get tired showing this thing. This is the robot exposed in year 2023 in China. Now, only show 3 minutes. 3 minutes clip. Let's see what I show.
Guangzhou-based Unitree Robotics delighted visitors to the show last year with a mass dance of 130 robots, and this year with an absolute novelty in the form of Unitree H1 humanoid robot and the Go-To robot dog, which is relatively accessible to the general consumer. Unitree claims to have spent only 6 months building the H1 robot, which was made possible by utilizing systems already proven on robot dogs. The company believes that their humanoid robot is set to start a new industrial revolution. From the main characteristics, height of almost 180 centimeters, weight of about 50 kilograms, maximum joint torque of 360 newton meters, 3D LiDAR plus depth camera, walking at a speed of more than 1.5 meters per second, and the ability to run. The company notes that combined with the versatile AI, the robot's range of applications could be expanded in both industrial and service sectors. We just unveiled our new H1 humanoid robot, and we want to use it in the industry in the next 3 to 10 years. We want to help improve industrial production. Unitree Robotic is a leading developer of quadruped robots, and the company itself cites its main advantage over similar products from competitors as the independent development of almost all key components, including motors, gearboxes, controllers, laser radars, and manipulators, which allows for a high level of performance at a reasonable cost. The most affordable robot dog model on the market from Unitree will be Go-To, whose price starts from $1,600. Even the most basic robot is equipped with 4D LiDAR, making Go-To's sensor system 200% better than the previous version. Go-To also provides a new human-robot interaction experience by combining AI voice interaction with a variety of movements and functions. Compared with Go-1, Go-To's new powerful battery life has increased by 150%, and the efficiency of the new joints with a maximum torque of 45 Newton meters has been increased by 30%. Go-To has many features for entertaining at home. Firstly, our robot is equipped with GPT and we can use it to talk to the robot. Also, Go2 has a powerful battery, so that it can keep working for 2 hours without recharging. And thanks to the 4D LiDAR, Go2 can scan any spaces. The Go2 is aimed at a wide range of consumers, so it has a relatively low price, and pre-orders are already open. We'll leave a link to it in the video description. System safety is extremely important to us, and thanks to the 4D LiDAR, it can avoid risks and keep a safe distance from children and others. Go2 with its battery weighs about 15 kilograms and can carry loads up to 10 kilograms. The robot is equipped with a microphone, speakers, a lamp and a front camera with an ultra-wide viewing angle and 1280 by 720p resolution. The company also showed the B1 industrial robot dog, which weighs 50 kilograms and can carry a maximum load of 80 kilograms. With a battery life of 2 to 5 hours depending on the robot's load, it can adapt to difficult terrain and bad weather, is highly mobile and flexible, and is substituted for humans in difficult and risky working environments. All of the company's robot dogs can be used for monitoring at industrial and other facilities, conducting inspections, and participating in search and rescue operations.
Okay, advertisement came out, so I have to stop it earlier than I should. Yeah. Came on playing. Now, could see that if you're interested actually about these clips, right? They have a lot of wonderful things and also amazing things being showcased in this WRC World Robot Convention 2023. Things are being revolutionizing in our world in past 1 decade. Less than 1 decade. If you still remember, if you're old enough to remember this thing, about less than 10 years ago, people talking about IoT as if it's one of the major things hoo-ha in the market, Internet of Things. And shortly after, people also about same time talking about blockchain, how we can actually dispute out our storage of data and computation, and in a more encrypted manner and safer way. And also, and from IoT, blockchain, people talking about edge computing, and the microcomputers and also IoTs being integrated so well, then we can actually dispute out all our actually computings in the different site in a very low cost manner. Of course, cloud computing also came into very affordable manners, things getting easier and easier to deploy, and we have more actually accessibilities to all kind of computing and storage area in a cheaper way, a convenient way than before. And suddenly AI came to play. And also all of a sudden we look at the robot. And I only show the robot dog is because it's so much you see in dexterity, flexibilities. The way is not because the way it mimic that like the living being, but it becomes something like science fiction is like not just like something that surprises us, amazes us, but it become really something that can come to a real productivity in real life. And in the video clips also shows that how walking robots, you could see like 10 over years ago, then Japan trying to came out with different kind of walking robot and very quite a bulky way, but we get actually amazed already. But in these video clips in the later part, it show actually walking robot could be so slim and lightweight, and also with the advancement in battery storage, and it becomes something that becomes practical as actually coming to your daily aid. Now, I'll stop here for about 3 minutes or so. Now I'll play a short video clip. Then later on, we come to go into how Wolfram technology maybe can help us better prepare ourselves into these new developments and adaptation. Of course, I'm not saying Wolfram is only technologies, but I have been representing Wolfram in the past 15, 18 years to see that, for instance, what Desmond showed yesterday, with the LLM technology built into Wolfram, the way actually you can actually learn something is so much easier. You're able to master something. The time actually needed, the learning time, is cut short in an exponential way. And Wolfram technology or Wolfram research has always been forefront in getting those technology available to us so we can become first-hand learner, also users, and probably also a developer. So I see you in 3 minutes time. So you take a quick short break. Now, also same time, play a short video here. So you don't have to watch it. You just can come back after 3 or 4 minutes. I'll see you in a short while. Yeah, thank you. Bye. Okay, well, come back after a short break. And if you do have any questions, you can just let me know. So if anyone of you like to type in the Q&A, I will take this chance to answer it before next session. For our next session, we'll break in three parts. First part, we talk about data analytics. Second part, we talk about networks and tree. Third part, we talk about AI and deep learning. Now, why data analytics? Why networks and tree? Why AI? It has very much to do with the 6 things I talked about, the latest development out there in the market. Yeah. So you come to understand why I'll come into the part about data analytics. Yeah. Data analytics is not something new. It's like everyone talk about data science about 4 or 5 years ago, talking about how sexy it is and how well paid it is. But how well paid is one thing. How could we actually become one of the contributing member in this new developments and these new exciting communities? Today is something like I would like to share with certain perspective. Yeah, maybe it help us to further explore what is possible out there, what is potential that available for us. Now, if there are any questions, you can in the chat room let me know. If you like to speak up directly, you're welcome. Just let me know. Is anyone? If anyone like to speak, then you can raise your hand and I will give you the mic. You can talk directly. Okay. Okay. Saw someone raise a hand. Tan Xiu Qing. Yes. I'll pass the mic to you. You can ask directly. Yes. Tan. Okay, it's okay. Maybe it's by accident. Yeah, you're giving the floor. Okay. If you like prefer to type it, you can do it later or during the next break. Next break will be about 35 minutes from now. Then you'll be given a chance to speak up again. If not, I'll just carry on. Okay. Now, if you look at here, why data analytics is, when I say is important and why also what's crucial is how can we make simple, relevant to us? Even though you are not in this field about data science, hang on, let me switch the screen again. You're not in data science or you're not particularly concerned about data analysis or analytics, but we all can run away. Eventually, no matter what kind of research and R&D you're working on, you're working on with the laboratory data, you're working on commercial data, and you need to make informed decision. This is how the whole things evolve on this chart. I always like to talk about the rationale of this chart. When the information in the world now is getting more and more sophisticated. Now, we're getting more sophisticated when information is getting more and more, then we are looking is how do we actually optimize based on information that we gather. Now, if we can push our information to the horizontally to the right, we are looking at optimization. So we look at tools at is that actually tools that help us to make sense out of the data, organize in a certain way. And also on the vertical exit is when the data getting optimized, does it actually help us make more better decisions? Can give a better result? The decision can lead us to more output, better output, or better quality. So we're talking about taking the value out of the information. At the same time, how do we actually optimize the information? Along these actually desires, these two important desires, we are pushing all the way from this part, reports and dashboard. Report and dashboard is as early as when we're still doing hand sketching, right? Until now, it's so-called Power BI or business intelligence. The concept is still the same. How do we actually gather all the information? Not just actually happening between my visually between my visual environments. We are talking gather data, could be like mentions that is from one corner of the world and in a very remote area, in a very far away. How do we actually get present to us real time? We are not interested in the historical data per se. We are interested in a real time data, and also want to actually help us to make a decisions between what is the risk we can manage. So we want something descriptive. Yeah, what will be the average? What will be the mean? What is the standard deviation? What is the upper chart, lower chart limit that we are talking about? And what will be the probability distribution look like? And we, in their case, that if we want to start doing modeling, could this thing actually be described into a formula, a probabilistic distribution? Then we can actually use this one to do some sort of prediction and describe how did it happen. So we can actually foresee what's going to happen. If we can foresee what's going to happen even with the new algorithm for machine learning, we can actually start looking at how we can do some prescriptions. So we could see that eventually when the whole thing is moving in this direction, we want a system able to help us. Can we actually help us make some sort of descriptions? No, prescription. Before things happen, we always actually want to take charts before anything happen at all. This is actually directions where it's moving to. So now we look at even with this thing getting even more prevalent with the introduction of ChatGPT since last November. Now we can see actually content becomes something cheap. We can even a 9-year-old kid, when they start learning actually ChatGPT, they will actually even like stuck with that. Stuck means that all the homework assignments, like my daughter this morning said, hey, how do you actually, I write one comprehensions with ChatGPT last night, so on and so forth. And you cannot say, hey, you cannot do this. They're already doing this without your consent. Yeah, you like it or not, they already doing this thing. So we are actually looking at this. See this annotation. Just give me 1 minute. Let me try to make sure I get a notation correctly. Yeah, okay, now it's correct. Now you will see the content now become very cheap, but what actually still add value a lot is still this: how do we actually comprehend the process and data well? How do we interpret this part? How we turn it into a model? How we actually describe it? How do we organize it and optimize it? Eventually become a solution that we can deploy. So this part is still, this day, a lot of people say, hey, junior people are going to get replaced by AI. It's quite true. When junior people, if we just emphasize on content creation, those things actually AI can easily mimic based on what we have done to come up with something with a similar pattern. But how do we actually make sense out of histories and turn into a process or model? We can use it for prescriptions and prediction and into the model that we can deploy. This is something still a very valuable skills that we require a deep participations of human being. So now that's why data analytics is far more than this. Now, if you want us AI to look on data, we ourselves not just able to look at data with the help of AI, we have to actually able to come up with informed decision with certain confidence. Why we are doing what we are doing? Why we are doing this? Now, for instance, here, what first part here, when we try to deal with data Wolframs, right? Now, if you want to able to actually satisfy the stakeholder, the source of data to all the way to how you understand, interpret data, eventually come up with decision, even come up model that have an organization to make actually faster, quicker, more accurate decisions. Is there somewhere like a workflow that make ready for us? Wolfram provide us a lot of automated workflow, or the workflow organized in very streamlined manner that we can actually easily understand. For instance, inside Wolfram here, for those who want to get started with this, actually a lot of so-called useful model. It can help us with a lot of built-in data available. Of course, data could be coming from anywhere. But the good thing is Wolfram built-in with a lot of repository. It's something like what you play with, like the Python. You have a lot like this GitHub actually repository. So Wolfram also have a lot of repository. Some are offered free of charge, real time. Some actually can upload by your own, and some people, others actually community. And this information here, for instance, is Old Faithful Gazer. So for instance, you say, hey, I want to have this data sample statistic of Old Faithful. I want to know what will be the eruption data and also inter-eruption data. So I can ask the system, say, I want statistic about Old Faithful. So what we have to do is like introduction like given by Desmond yesterday. So there's only a few click button. The system start actually running, everything is on its own. Let me switch on some of the unnecessary things so that it can go smoother. Okay, here we go. It took much longer than it should. It's a lot of things running in my memory. Now, the thing here is you do not have to actually concern about coding. You rather you pay attention to the workflow. Because this is like Python, same thing. There's a certain syntax you need to get familiar with. And once you get familiarized, the approach is universal. Yeah. So for instance here, I'm interested, not just first thing that I'm interested in the first column data, which is eruption data. And the second column data is inter-eruption data. So now, let's say I would just want to look at the total duration eruptions and this Old Faithful Gazer. So you have 3.6 minutes all the way to 10 minutes or so. So if I want to come up with some sort of, I say, hey, can you give me what's average time of the eruptions? Is 3.48 minutes. Yeah, each eruption is lasted that long. So let's say, secondly, I want to know the second column. Second column is the inter-eruption time. So I say the total duration between each eruption. So I say this is called waiting time. I define a user variable called my waiting. So after that, I can ask system give me the mean, the variance, median, skewness, kurtosis, first quantiles, and second also last 9.9% of quantiles, so on and so forth. So these are basic statistics. You can even do with calculator, nothing much. But now I'm going to come to this very basic workflow all the way to how do we turn it into a useful model? We can use it for prediction, for simulation. Now, important here, for instance, here, this is not in annual income. Sorry, a typo. Now, if I want to look at what would be the probability, and I want to look at probability density function and cumulative density functions, cumulative distribution functions. This first one, it gives us the probability of the interruption time. So we see that the probability like this is like between 75 minutes to 80 minutes. We have about 0.19 probability that's happening between this time. 80 to 85, we have about 20% of probability. And we also look at this slightly peak here on this side. Yeah, so between 50 to 60, these probabilities happening. So we could see here, this is quite an interesting actually probability visualization, the system that give it to us. Now, if you further look down here, this is like PDF file. They also give you a PDF. Now, of course, if you look at the visualization probability and the PDF, they'll be the same. Only thing is this is a probability density function. So you can see that 60, if you look at here, from 80 to 85, for each of the, based on, let's assume there's a discrete unit, 80, 81, 82, 84, all having a chances about 4% happening, and also cumulative distribution functions. And now, very important thing, you need to start asking questions. Say, hey, I want to know what's the probability when in the eruption time, I have to wait for 50, 55 minutes for waiting. What will be the chances? The system say about 11%, 11%, you have to wait that long. Now, what will be the chances I have weight between 50 to, let's say, I want to make to be like slightly awkward, 85.45. Could we answer this? Yes, system will answer that. It say will be about 81%. You'll be waiting between 50 minutes to 85.45 minutes. Now, it turned into the model I can actually ask for certain risk management already for the purpose of risk management. Now, the next thing is, of course, here I will not go into very deep about data analytics. It can go a few days on this particular topic. But I just like to point out among 6,000 over super function built by Wolfram, it helps us when we try and deal with the challenges of coverage, distance, accuracy, automation, speed, and intensity, and so forth, so and so forth. How could these super functions help us to actually help us deal with better, help us deal with this challenge better? So for instance, I want to point out one super function is called find distributions. Now, inside here, this super function called find distribution, you can automate find possible continuous function. There are so many functions available. Automate find possible discrete distribution. No, you cannot easily achieve this with some other packages or open source. So as far as I'm concerned, maybe some people wrote it somewhere in certain GitHub, I cannot find it. But so far I've not seen it. Now, if we here, now, it's not annual income. Let me just switch off this thing. I'll switch off this thing first. Now, let me see. I'm not too sure I still have this. I think I do not have this. Now, I'll skip this part first. I skip this part. Now, in this case here, with this super function called find distribution, what does it do for us? Now, there are many super functions like that available inside Wolfram technology. But let me point to one example here, then you'll know what I'm trying to do. For instance, here, if we say, hey, Peter, I like to actually build some, for instance, this people are talking about renewable energy these days. We try to harness solar energy. A lot of countries try to harness wind energies. Now, before you actually decide where to put a wind turbine, you want to choose a places that is consistent and windy. So now, is it possible for us to choose a place in Malaysia? Now, let's say I choose a place somewhere in Kuala Terengganu. Now, again, you see, I put in Kuala Terengganu, Peter, where you get this information from? Now, this information here, like I say, this day, there are technologies being made so much friendly available to us. Yes, we can achieve a lot of wonderful results. And if you are actually good in the domain you're looking at, you also like almost like genius in coder. It's hard to find this combination. But the good thing is, now, with this thing available like for technology like for us, like for instance, I say, hey, Glang. When I put here Glang, the system somehow understand. I just, if you want to actually code somewhere, say, hey, can I get somewhere connectivity issue? Let me just try to see whether I can get somewhere. Let me say Batu Pahat lah. Okay. My internet connectivity got problem because now let me see whether it works. Now, if I put the system, if my internet connectivity correct, the system able to pick up the GPS coordinate. Yeah, this system developed, like say, proprietary software by the US company, but it seemed to understand almost 200 over important city in Malaysia. Also, if you say I don't want to put in the city name, I put in actually GPS coordinate, can or not? You can put in. So now I put in this city name, you know that one of the alternative name in Batu Pahat is called Bandar Bekaram. So if I say, hey, is there any weather station there? I want to know if I want to get certain data, where does it get from? The system able to tell nearby Batu Pahat is a nearby weather station. So I want to know where, for the next information I want to get from, where does it get the data from? So in this case, when I try to pull out information, next thing here, I say, I want to get the average wind speed from Batu Pahat. So same thing, I'm going to type in something, a command here, I say Batu Pahat. So this is something like almost like, it's not exactly AI, but it's close to AI. Yeah. When you type something here, the system search for the internal actually available information data. You know, this is play here called Batu Pahat. I want to get the average wind speed. And the thing is, you say, I want to get the average wind speed for the past 13 years, starting year 2010, 1st of January, in a daily basis until today. Yeah, this is like today date. Yeah. imagine here, you want to get about 4,000 data points, like past 13 years, like 365 data points per day. You want to get this data from somewhere, almost next to impossible. Now, my system somehow I get lagging. Every time we turn on Zoom, we have issue. It's like fighting for memory. So let me see. Good. Okay. The finally come. I hope it won't take too long. It's like too much. It usually take less than 2 or 3 seconds. Now, 85 kilometers away, the nearest actually stations, weather station, but doesn't matter. Doesn't matter as long as data is available. It doesn't matter how far this weather station. Just like telling you, the system understand a lot about geographical informations. So now, it's not just actually having geographical information, it actually keeping in the actual real-time repository from a lot of important sources, trusted sources. Like in this case here, altogether 5,089 data points, starting from 1st January until today. If we go and talk to any authority in Malaysia, so I say, hey, can you give me like a weather data, particular place, for past 1 month, good luck lah. They will look at you like crazy. What am I obligated to give you this data? But now you look at here, this is actually the repository actually organized by Wolfram free of charge. If you are like say you are if you own a email, you're able to get these actual informations on your fingertips. So this is like average wind speed in the past 13 years, starting 2010 in Batu Pahat. Now, you can see the wind speed here is like meter per second, between 2 meter per second or the 12 meter per second. If you say, hey, could I look at actually moving average? Yeah. Now, instead of 52, previously I thought I want to put a 30 lah, like monthly basic. Now, I want to see is there a trend that the wind actually pattern got changed over the months, over the year. So because in one example I'm going to show later is like, do we have rising sea level in certain areas? It seems to see that actually like our East Coast Malaysia, where when it put in 40 years data, we're moving average of 52 weeks, we see the sea level seem to have some cyclic pattern also. That's an interesting research to do. But in this case here, if you want to turn a moving average of 5,000 records, system will give it to you in a 30-day basis. So the wonderful part is, if you say, hey, I don't want to get 2010, could I get 1980s? So I want to get all together nearly 40 years of data if possible. Yes, you can get all the way to 1970, even 1960. I even tried to get 1957 before our day of Mathematica. We still also have it. Yeah. Now, only with certain days, with certain missing data. Now, here it seems to show that these are moving average. Now, I'll put it aside. Now, if you want to look at descriptive wind speed, same thing here. I want to look at mean, standard deviations, median, skewness, kurtosis, quantile, so and so forth. The system gives information. Oh, my mistake is not meter per second, it's kilometer per hour. Yeah, this is a default unit measurements inside this repository. So we look at here, the average wind speed Batu Pahat 5.4. Yeah, but we know it seems to have a cyclic pattern. A certain month windy, certain month lesser. So we know there's actually a pattern, cyclic pattern here. Now, with this cyclic pattern here, now we say, okay, now if you want to extrapolate, take away the unit measurements, because system that now for system to play smart, right, the system had to understand, make a lot of automated processes, pre-processing or post-processing. For instance, now you say I know the average wind speed is in the unit measurement kilometer per hour. Can I convert a meter per second, or I do some sort of multiplication with other unit measurements such as feet, such as other things like old British or US metric system. The system automatically convert for you. So now I say, I'm going to take out the unit measurement. So I don't want you to do any conversion automatically for you. So I just want to go straight like that. I say, can you tell me what is the probability I have wind speed more than 5 kilometers per hour here? You say 51. Now, if I say I put a 4, the system says, 75% of time, nearly 76%, is actually above like 4 kilometers per hour. Let's say I have certain wind turbine. It to be effective, it need to be 7 kilometers per hour. So I know I only have less than 20%. It might not be an ideal place, but it's okay. It's okay. I say, could you now using the super function right now, just I talked about, called find distribution. Now, I don't want to look at to make the system be something a QE and answer thing. I say, could you give me a mathematical equations like I can actually represent it in mathematical manner. Give me a distribution. Now you will see the whole pattern here, right? If you want to come out with any distribution, it's very hard. It have a cyclic pattern. You also subcyclic between cyclic. Very hard. So the system here, between less than 5 seconds, it came out with something to try its best to describe. It say, is your system here seem to be a mixture between normal distribution and log normal. Now, of course, this parametric distribution, it give you parameters as well, things like that. Also give you a weight. This is weight. It say the system had a weight of 0.76 toward this normal distribution and a weight of 0.23 toward this log normal. Now, they say, okay, fine. Now, if this is a distributions, yeah, can I actually turn it into a probability density function? So I can mathematically try to describe it. So system say, oh, this is how it looks like. Yeah, this is probability blah blah blah, probability density function. If this thing is less than 0, of course it's not true lah. Now, but because the system look at data here, it say x is less than 0, then it will be this formula. If x is not at 0, this is the formula. So at least it's certain mathematical equations come out. Now, we say, okay, I want to visualize it. Now, I want to know, based on the historical data, what is the minimum kilometers per hour to maximum? So we see in the past nearly 10, 13 years, right? The ever highest speed of wind to recorded Batu Pahat 17 kilometers per hour. That's like thunderstorm or like hurricanes happening. Yeah. Also, with less windy day is the minimum 0.19. So if we are using this formula, this PDF formula, probability density function, I say, okay, now I'm going to put in between 1 kilometers per hour to 225, put in a range. I say, can you plot with me with this particular distribution you created for me? So system plot it like that. Yeah, this is based on the find distribution, the super function that have provided for us automatically. We turn to PDF, probability density function, and it can able to block it mathematically. So we can see, oh, this is how it looks like. Now, then of course, we are less convinced. We say, hey, can you put this thing with our histogram from raw data together with this plotted PDF? It seemed to match quite well. Then we say, could I use this actual equation to actually put in my Excel spreadsheet and Python somewhere? As long as mathematical equation is available, then we can deploy it. But now, if you are actually have some common sense statistic, we know this find distribution, you start questioning, is it valid? Yes, I know it's automatic, it's wonderful, but is this valid? Now, this is the workflow. Of course, in these trainings, usually when I train on this particular probability and statistic, right, it will take us approximately about 3 sessions now. But now it's just quickly let you have overview. So we could see here, this is entire quick workflow that we can come out with. This workflow is like, from very beginning of data wrangling, how to do clean and transform data, come up basic descriptions of the data. Then we can use super function of various tools to construct the distribution. Then after that, very important part here is, could we actually, in a way, now we use we come up with hypothesis testing. Whether the things that we are talking about, the system come out with the distribution and PA, is that true or not? We want to test it. If we test it, we're going to say correct, then we're going to use a PDF that the system came out with to deploy as something that a practical solution that I can put inside other system to run. Now, having this in mind, now the next step in this the workflow is we're going to see how we're going to actually use this actually find distribution for this example. For instance here, now, in this case here, you can try to Google it. Very difficult to find it. With all those little point you will see here, these are things I'm talking about. Yeah. I really appreciate that much, right? The Wolfram actually somehow they it took so much effort to make this actually working it not just actually for primary users from certain country, but also for Malaysia. This little dot here, this is actually a station that actually deployed by Malaysian government to measure water sea level. Yeah, this is important because the sea level is not just for this meteorological purpose. Also, it actually it's nothing to do. I'm not sure it has something to do with this tsunami warning. Or not. I'm not sure lah. I'm not sure. Could be. But this is one of the actually map I find it in one white paper deployed by a research published by researchers in a particular pay portal. Yeah. But if we go outside, go meteorologies and some of the available public government actually website, you cannot see this thing. No? Say, hey, where are the sites that station measuring sea level? We do not know. We do not know. But Wolfram knows. This actually supplies a lot. Now, you can ask the station where they are. For instance, right, you can ask if we are concerned at East Coast. If I say I'm in Terengganu, right, I say, hey, where is nearby stations? Can you tell me the name and where they are? Same thing, like you're asking for a weather station. You go and tell the information there. Now, in this case here, it show actually these particular stations, what's the name and nearby, but let it run. Again here, if I want to get a weekly basic water level at Kuala Terengganu, and weekly basic means that for past 10 years, about 500 over record. So I want to make today demo faster. I don't want to go that ambitious. Can go past 30, 40 years, no issue. So I make it to be like something lesser, like say from year, let's say 2018. I just want to get it in the past maybe 6 years, so that's okay. Now, again, sometimes this thing have internet connectivity is okay, say network operation, blah, blah, time out. Well, we don't care. I'll just get this one ready. For the past uh 6 years data. So 6 years data, we're talking about nearly about in this case 52 weeks weekly data. You get about 3,000 data point. Let's be patient. Just wait for that. Because you need to retrieve from a repository somewhere, depending on the how busy the server is. So sometimes the latency sometimes will be longer, sometimes be shorter. And also it also depends on memory computer. So that's when I realized every time we turn on Zoom, right, this thing seems to sometimes take much longer time than it should. Not sure why. Okay, same time, if you have questions, you can just let me know. Now, I would not want to wait for that. Let me just switch off this thing. Okay. The first part is off. Missing, not available. Let it be. The system get aborted. Okay, let me just retry this thing. Okay, I'll try one more time. It's hard to predict when is the right time of day, sometimes to find the server with more capacity. It's very hard to find. Just like last time, I want to make sure that it won't take too long, and I put in like 10 or 15 years data. It would just take like less than 15 or 10 seconds to get data that I wanted. But let's see. Okay, when it's running, the network timeout again. Okay, it's not behaving. Let me just close this entire application. Try to free out some of the data. Free up my memory. Hmm? Okay, let's try one last time. If not, I'll skip the next one. So, so we can carry on as schedule. Huh? I think it's okay. Okay, let's come to ocean sea level. Now, Desmond asked me, should I queue the file to you all? Now, unlike yesterday, today, it involved actually it's slightly more advanced because like I take away some of the minor steps. I jump straight to some of the code directly. So the code itself, if you already have basic background about Wolfram language, it is quite straightforward. But if you are not, actually, it's slightly for you to go around, it might take some effort. But if you insist, say, hey, I still want your file, yes, I'll be happy to share with you. Now you can talk to me in private, then I'll be happy to share with you some of the files, but not all the files, because certain files, they are interconnected. So it might actually require some understanding about where you should keep the file, where you should import the data, things like that. Okay, I'll come back to this part here. What we are trying to do is, after that, we're going to see what will be a tide level, what is between 2 to 3 meters long, high. After that, we are going to use something called phi distribution again to see that could it actually give us a distribution, describe it. After that, we say, okay, if this is a distribution described, the system come up with, can we convert into a probability density function, yeah, in terms of x? So then we can actually see, we can use this one to do some plotting. When you plot it, right, again, I say, visually seeing it whether fit is one thing. But we want to use some hypothesis, like goodness of fit hypothesis test to see that whether the data we actually gather for past 10 years or 8 years right now about sea level, does it agree with the distribution of probability density function that we came up with? If we say, okay, it passed the goodness of fit hypothesis test, then we say, oh, we are confident to use this actually PDF probability density function in terms of X, yeah, to deploy the any other system you want it. So you only have to put in X, the system will give you what will be the predicted ocean level at quantum nano. So this is the whole idea. We don't want to do an analysis per se, but we want to actually use it something that deployable. So again, it's really time out right now. I'm not sure why. And again, the server is hard to us predict because of free thing. So sometimes we can't complain. But this thing rarely happen, only once in a while. So I'll leave it like that. Later, if it works, I'll come back to that. But now, we'll come back to the actually last two example. This is also a very interesting example. It's actually related to our life. For instance, here we look at the inflation in Malaysia. Right now, everyone talk about inflation. When Chinese New Year is coming soon, you see the whole market, people complain about, oh, ringgit getting so small, compared to USD, we get depreciated every day. Any news out there in the world, Malaysia ringgit always get affected. Yeah, people at war, our ringgit also affected. People at peace, our also ringgit get affected. Always get affected. This is a reality. So if you want a system to say, hey, we don't look at the depreciation of ringgit only. We look at our actually in terms of inflation based on the official inflation percentage published by Malaysia government. Yeah, in the since 1980s, in that time, 3 ringgit, if we keep adjusting, right? Don't talk about currency, talk about inflation rate only. How much actually we had to pay for the same thing that worth 3 ringgit 40 years ago? The system says 3.56, but we know it's much more than this. Yeah, 3 ringgit in a time we can eat a big plate of nasi campur, but now if you want to eat nasi kandar, 15 ringgit also sometimes there's no change for you. But now, how about currency and Malaysia ringgit? Now, these are things that help you do a lot of business economy analysis. Of course, I'll show you a very simple thing. And you want to go further deep down data analytics and finance and economics and business, that's another topic we talk about. And we also have a lot of automated tools built-in available for us. For instance, here, we want to look at the currency since 1980s. If you go any websites, right, the information only available up to that certain years. Now, I think the server is all down today, so we're not able to retrieve it, unfortunately. Let me try one more time. If we want to look at actually currency exchange between USD and Malaysian ringgit, since 1980s, right, nearly like 43 years ago, until today, what would be a trend like? If we go for like certain website, right, quite likely maybe it gives you like up to the past 20 years, past 30 years. If we want to go further, right, it might not be available. Let's see, you can give it to us. Now it's like, if it can come out, then we can actually show it. After that, we can turn it to be actually deadly plot. We want to turn the time series and to show to us that how does it look like. And we want to turn time series like, then we say, hey, is that a way that we actually can do prediction? Now, we know traditionally there are a lot of forecasts actually algorithm available, for instance, called ARIMA. Now, the information, let me see, try one more time, see if we can get it. The network actually is not in terms with us today. Let's try. If this thing can come out, then we can go on next thing about using ARIMA to do prediction. Because everyone talking about prediction, Malaysia ringgit versus USD, and in a very heated manner in the past 1 year. Everyone have different prediction. Of course, if we're talking about a geopolitical reason, there are many things affecting the performance of Malaysia ringgit. And you look at technical thing per se, we say, okay, put aside all those geopolitical issue, right? And can we technically actually predict what will be the performance of ringgit? This thing is where like I did it just like by 1 hour ago. This will be the prediction of Malaysia ringgit for next 2 months. Yeah, in a sequential manner. Yeah, 4.37 things and blah blah blah. Let's see whether it come out. No, it still won't come out. So I'm not able to show the prediction how it works, but fortunately, this is one of the result that I get previously. And with these things, supposed to give us the visualization, upper limit and lower limit, but seems to be not running. And the next thing here, let's see. Before we go to the next break, this is another thing is a showcase, right? A lot of repository, not just actually get prepared by Wolfram, but there's a lot of public repository Wolfram can easily actually connected with. For instance, this one is like a very special project done by Google until they stop it already, but it's still available in the website. When I say stop it means that they collected all the published sources between 15,000 all the way to 2019. Yeah, just a year before pandemic. They put in Google Text Corpora in many languages, I think including English, of course, is prevalent, Russian, Spanish, Chinese, things like that. if you go to this website, right, you could see that this all the actually available officially collected tax corpora, yeah, available for the past nearly about 500 over years. So if this all this text available is digitalized, right, could we actually find out a keyword? Now, I hope this thing can come up. Let's say there's a super function called word frequency data. I want to know these two words, gelang and gelang, yeah, since 1960 in a published corpora, how frequently does it show up? Now, I hope the server is up. Let me see. Now, if it's up, it's supposed to actually tell me that what is the frequency of gelang and gelang actually get detected in the officially public corpora in since 1960. Yeah. So then we could see how this thing actually evolved along the period of time. And certain language where certain keyword get come up and come down has a historical reason associated with historical event. For instance, using this case, right? For instance, I'm interested about the whole servers down, but you get the idea. But later, if after break time works, I'll try to show that again. Also, that about disease are human, yeah, disease are human. HIV, smallpox, tuberculosis, cholera, malaria, and I want to show you in 1940s, right, how this thing changed. How does it go up and down? Of course, the information collected by Google, right, only up to 2019. So if we want to put in something like our pandemic related actually keywords, that it will not show up. Yeah. So same thing here. I want to show the chain, something that's associated with the chain of technology, like TV, television, phone, telephone, mobile phone, and even this thing called fax mile. I think this become a vocab to a new generation. You have not even seen it before. What is fax mile? It's a fax machine lah. So let's see. Let me try it one more time. See if it works or not. Does not work. Yeah, it's okay. Now so much about data analytics, and we'll take about 10 minutes break. And at this moment, I'll take a chance to answer any questions that you may have. Then you can go on. See you in 10 minutes time. Yeah, any questions all about data analytics? For the next two part here, I'll start second part, show about, share with you how network and trees. Yeah, of course, network and tree is one of the uh, uh, important elements called graph theories under this discrete math. Yeah, discrete math we know is one of the must-have compulsory module for people study computer science. But the thing is, like say, looking at this advancement of technology related to digitalizations and automation, IoT, information technology is something here to stay. Yeah. So a lot of actually things related to like discrete math, when come to application, become very, very important, much more relevant and practical to us in this 10 over years. So later on, I share with you in a very practical manner, yeah, how this discrete math can play in terms of networks and graph can become something so interesting and intriguing. Of course, it nothing to do with server. We don't need to download data anymore. So the second part, no issue. Yeah. So I see you 10 minutes. If you do have any question in the chat room, you can type it. Let's take 10 minutes break, then come back. Then I see you later. Yeah. Okay, bye.
Look.
Harder for me, oh, harder for me. Maybe we're over it, or maybe just lovers, cause under the covers, baby, you're showing me how to be fearless, so no one can hear us. You're throwing the pillars through the floor. Now put your loving on me, eh, loving on me. Maybe you won't see me get emotional, and sometimes I pretend I'm just above it all. But I want you lying next to me. Yeah, I want your body, body, body too. Yeah, body too. And baby, please don't think I run away from you. It's just sometimes I get scared to dive into it. I want you lying next to me. Yeah, I want your body, body, your body too. Yeah, body too. Will you be my ride or die? Around all these people, we'll try to be someone better than you and I. Posing for pictures, but nobody listens to anything that you have to say. Can we just leave and walk away? Walk away, walk away. Maybe you won't see me get emotional, and sometimes I pretend I'm just above it all. But I want you lying next to me. Yeah, I want your body, body, body too. Yeah, body too. And baby, please don't think I run away from you. It's just sometimes I get scared to dive into it. I want you lying next to me. Yeah, I want your body, body, your body too. Yeah, body too. From my window, sun's coming up like the day before. You're like a stone on my pillow. I don't make a sound when I shut the door. You don't have to wake up yet. We can spend all day in bed. I'll put the TV in the room. We'll have a Netflix marathon. Kenny G saxophone. We'll order in a bunch of food. I'll put your favorite music on all the way baritone. Yeah. Shut the lights, go infrared. We can spend all day in bed. I get the wine and the corkscrew. You don't have to do one single thing. You don't know how much I want you. Just looking at you makes my whole world spin. You don't have to wake up yet. We can spend all day in bed. I'll put the TV in the room. We'll have a Netflix marathon. Kenny G saxophone. We'll order in a bunch of food. I'll put put your favorite music on all the way baritone. Shut the lights, go infrared. We can spend all day in bed. I'll put the TV, Netflix marathon, Kenny G saxophone. We'll order in a bunch of food. I'll put your favorite music on all the way baritone. Shut the lights, go infrared. We'll have a Netflix marathon, Kenny G saxophone. We'll order in a bunch of food. I'll put your favorite music on all the way baritone. Shut the lights, go infrared. We can spend all day in bed. Searching for something that ain't lost. Have we got it? Our lines crossed. We're wasting time on stuff that doesn't really matter, while wishing for something better. I try to fix things that weren't broken, misunderstandings and words unspoken. We fall apart, and I won't dare to say, do you feel the same way? Maybe you don't wanna know, but you don't see what you have in front of you. Or maybe I'm not enough for you, so maybe I should go. If I had known from the start, this wouldn't have ended with broken hearts. 'Cause I don't wanna waste my time. If we don't feel the same way, then don't pretend that everything's okay. Don't string me along the way you do. Just let me get over you. Maybe you don't wanna know, but you don't see what you.
Welcome back. All right. I have good news. Yeah. The server seems to be back. So I'll just quickly show I quickly go through what we actually supposed to run just now, but it failed just now. So let me try to not sending out.
Your chat message is always sent to panel.
Oh, it's okay. Just now I sent out a file for those who want to try it. So I'll ask Desmond to help me forward again. Just now I accidentally sent it to another group, so it might not have it. Now, before we go into the network in tree, like I say, the good news is that the system seems to server back to line. So we will just quickly see what equal to us. Now, we come back here to about this sea level one more time. Yeah, sea level. Okay, this is wind speed. Let's come sea level to see that it works actually as what we claim or not. Yeah. Oh, wonderful. Yeah. Gendering in Malaysia, the Equatorial. I think gendering is up here. This particularly see that. Then on this little dot up here, gendering. Yes, this is the area there where it collected the data from. So very importantly, we'll see the next thing is, does it able to give us the weekly data? Yes, wonderful. Even the weekly data now is available, and altogether have a data point 314 weeks available collected in the past this altogether 6 years or so. Yeah, 6 years, past 6 years. So we have this 6 year worth data now available for us to see. We can actually do further analysis or do some visualization accordingly. So now we see that how could we actually plot the time series. Now, in this case here, the data imported 314 weeks. Then we say, okay, if we want to visualize this, how it looks like. Now, the sea level detected data connected to generating stations in measuring the ocean sea level equatorial. If you want to put into the weekly basis, not weekly basis, 50-week basis, we seem to be the sea level been rising equatorial. Yeah, it been rising approximately about in quick glance now. It seems rising up and down approximately about 10 centimeters. Yes, quite apparent. If we put in like 20 years, you can see the pattern even more apparent. But we put that aside. So now, if we want to look some sort of information, descriptive informations, then we see the average sea level throughout entire season, like monsoon season, non-monsoon season. Average output is about 2.23 in the past 8 years or so, past 6 years or so. This is like average ocean's sea level. Now again, our interest is actually trying to do quick analysis. Could we actually turn this into the model? Let's say I want to find out if the sea level between like 2 meters, more than 2 meters, and less than 3 meters. What would be the probability? The probability is like 45%. So now we're going to use a super function right now. I say, hey, could we actually come up with the distribution? Yeah, probabilistic distribution describe the sea level equatorial in the past 6 years or 8 years or so. What will be the distribution we come out of it? So systems say that could be a combination of 3 normal distribution. We know this whole thing is cyclic, so you're not surprised that actually complies multiple normal distribution. You had first normal distribution, second normal distribution. Say, okay, fine. Then could be able to turn this into the mathematical equations, probabilistic density function. It seems to be able to generate it. Now, we say, okay, if this thing is generated, we want to visualize it just like the way we visualize the wind pattern. Now, we could see this combination of 3 normal distributions like that. Yeah. So we could see that if we want to look at what's happening in the PDF manner, this is how will be the PDF pattern of ocean sea level equatorial in the past 6 or 8 years or so. So we say, hey, if we want to compare your raw data, what does it match in terms of raw data? It seems to actually matching quite well. But again, statistically, we still want to do a test. You say, this doesn't pass our test or not. So we can use a super function here, like called distribution fit test. So the system seems to agree quite well. Say, hey, the p-value is like quite large here. Now, then we see, could the system give you some verbal description? Now, the important thing here is we need to know the system is like generative AI. We might not be actually expert in domain, but somehow we want to do some basic analysis. Could the system actually, in a more conversational manner, tell what its conclusion is? So the final conclusion is, hey, the number of hypotheses, the data is distributed according to this particular distribution. We say it's not rejected at 5% level based on the Kramer-Von mind state test. So we say, okay, quite well. I can actually use this actually PDF confidently to actually deploy to any other system I like. So I can use this one as doing like prediction of the ocean sea level at no. Yeah. So this is like something that we feel happy about. So now, same thing here in this forecast here, just now is where we left off. We say, could we extract historical US currency and Malaysian ringgit? Yeah. And now, we need to get these informations like Malaysia ringgit, start year 2018, 1st January. Let's get it. We get first. Altogether, it's 12,000 data points. Yeah, it's about, then we say, could we block it for the past, this is like past 43 years worth of data. So if we want to see it, how does it look like visually? So then we can see that how Malaysia ringgit has been performing versus USD in the past 40 over years. So later on, then only we use ARIMA or any other actually forecasting algorithm to do the forecasting accordingly. So the system try to generate a chart based on this 12,000 set data. We can see that, oh, this is how the currency go up and down. In 97, 98, we have this economic crisis that Malaysian ringgit shot all the way up there when it get depreciated against USD. Then we say, okay, based on what's happening right now, we want to take a look actually and help us predict based on the performer Malaysian ringgit. Let's say based on the pattern, we want to see how we will predict it. Yeah. Now the system come up with a model here, temporal data. Yeah. Because certain data, right? For instance, there are holidays, no trading days. Certain days there's no diffractions of Malaysian ringgit performance. So the system automatically perform this interpolation. It says data is not uniformly spaced, so it will be automatically resample to a resolution and minimum time increment. So the system is actually quite intelligent. It will do a lot of pre-processing even before we ask it to process it. So data are able to do, okay, based on what we know, let's say the performance Malaysian ringgit since 2021 is going to do a prediction is what's going to happen in the next few days to come. As we say, we want to predict for next 2 months. So visually, it looks like this is how Malaysian ringgit, technically how it looks like. We say, okay, let's do it in these 2 months. We want to break it down in weekly basis. And this is how it looks like. We say we want to put in some upper limit, lower limit. So this, of course, is technically predictions between a 4.61, 4.93. So there are many other things here. For instance, just like I mentioned here, if I want to look at the connectivity to the Google's text color, that looking at a certain keyword, then this is fantastic. It can show that the traditional word called gelang, that is actually coming up and going down, almost die off. People seldom use this word gelang right now in the publication, but this Kelang is actually official name of this city in Selangor right now. So same thing here, if we look at the technology change, yeah, so we put, say, hey, could we use this word frequency data, which I mentioned is one of the super functions, then we could see how technologies rose and died, yeah, throughout the past few decades. We can see that, oh, the keyword, like for instance here, there are certain keyword like this one, phone, telephone, mobile phone, it's like going up. A lot of applications talk about mobile phone. You talk about green color thing like fax, right? It is going up and now almost died off. No one talk about fax anymore in the official publication. Same thing about email. There's certain time they're going up, and now it's almost died off. People don't really talk about email that much already in the official publications. So this is something that we look at here, what perform data analytics, the entire workflow is very streamlined. So next thing here is, hey, Peter, if you talk about this case, now, how network actually plays a part in so-called Industrial Revolution 4.0? Because after all, this topic in this 2 days is, we want to focus here by realizing what's happening out there in the market, especially with this revolution Industrial 4.0 and also the new challenge brought by AI. How could we actually be more exposed to important domain of technologies and know-how? Now, network and graph is something that sometimes people tend to overlook because people thought, hey, this only belongs to the domain of computer science. But we can see here, in fact, this particular, when under the graph theory, right, It's gaining more and more actually attentions when people want to do, like, for instance, analysis in sociology, physics, ecology, economies, right? Business informatics, even bioinformative, right? Not just traditional like computer science, people want to do data design, data mining, and web mining, so on and so forth. But they are getting more and more, especially in the era Industrial 4.0, that graph theory, it becomes something very practical. And why does it matter? If we look at this entire market, this is one of the publications done by a company called Market and Markets Analysis. It was published about 2 years ago, I think 2022, if I'm not mistaken. The growth of the technologies in the markets related to uh, network, and trees is gaining more and more attentions. So you look at this market worth, right? This is, we are talking about, for instance, the market here, we are talking about nearly like 600 millions in year 2019, and it's going to expect to reach this year 2.4 billion. So it's talking about total investment related to the technologies and talent developments related to this whole graph analytics market. Of course, it also involves some so-called this graph-related database, things like that. Why people need that? Because people need to do a lot of like customer analytics, risk and compliance management, recommendation engine, raw optimization, and fraud detections. So if you look at here, even that today, like any very seldom us we don't buy things on website. Almost all of us one way or another, more or less. And when it comes to actually more and more actually this so-called online business related, the logistic and warehouse and also entire supply chain need to support this thing. So raw optimization, also like online transaction fraud detection is something that become indispensable for us to further how find way to optimize it. So if you look at few things here, with the actually change of the society this day with Industrial Revolution 4.0, we need actually more and more automated system able to spot frauds and criminals in unlawful action. Of course, AI play a part, but in addition to before the AI algorithm come in place, right? We look at all those actually numerical data, all the information available in database. Could we actually using this graph theory to spot some fraud and criminals and some unlawful actions accordingly? Of course, we know AI can do it pretty well, but graph theory also can do that. Yeah, analyze communication activities, like other things like marketing, operation, healthcare, and disease. And if we further look at here, like the basic actually come down like this. For very basic things, right? The traditional thing that we are dealing with, like how to actually understand about graph and network and trees. Can we actually have a tool that easily model it? Then we can analyze it, and finally we can deploy it either in local machines or in the cloud computations, a server. This is something again becomes another important workflow. If the workflow can be streamlined and also the whole graphic user interface or user interface can become actually built in with the advanced technology like AI, right? We can actually turn our concept, our thoughts, our pattern or generalization into something a practical model in a very simple way. So I'm going to show with you now how could we achieve this now. For instance, here, these are common things. Using a graph theory, people usually do centrality analysis. If you are not unfamiliar with graph theory, these are common things like community detection, connectivity analysis, path analysis, and so on and so forth. But you say, hey, nothing to do with this area of study. It's okay. Let's go into a practical way. Hey, I'm sure this is related to you. I'm sure later. Yeah. For instance, here, if you look at things as a matrix, right? If we want to study a graph or network, we can use this matrix represent it. Now, this metric 0101 is simply to tell that how each vertex or how each node is connected to one another. If vertex A and vertex B or node 1 and node 2 they are connected is 1, not connected 0. So for instance here, if we have so many like altogether we have 10 vertex or 10 nodes, or so-called in more layman term, you have 10 locations. To determine how the internet interconnected with one another, we just put 1010 true and false. So the system now, by looking at this, right, now it can actually, when you turn to visualize it, it simply come out with a way that a map or some interlocated locations or nodes or vertex, right, connected by edges, are connected by lines, like lines. So we can see how each location is related to one another. Now, when you look at this edge or the path that interconnected each location, right, then we can know, oh, each of the path might have different costs associated. For instance, the travel from location A to B could be more expensive from traveling B to C. Or you can travel the A to C, but C cannot travel back to A. There are a lot of constraints you can put it in terms of cost, in terms of speed, in terms of distance. Suddenly, this whole thing becomes complicated issues. If I want to travel from one location A to Z, how many ways I can travel there? What's the cheapest way to travel there? And what's the quickest way to travel there? What is the optimum, actually, maximum capacity I can move certain things from one place to another? Things could be as simple as logistic issue to a whole national security strategy issue. For instance, as early in the First World War, people want to study about the railway station in Russia. When Russia get engaged in a war in the actually Eastern Europe, sorry, not First World War, Second World War, people want to study among all railway stations with different capacity, how well could Russia actually mobilize their militaries resources from the west all the way to east? Those involve graph also. Yeah. So things could be as small as the things we're looking at graphic here on the screen, could be actually as important as national security issues, also counter-terrorism strategy, things like that. Now, to make things very quickly how it works now, I use the same way, right? Now, if you look at here, this is like called Chinese Postman tool. Now, this algorithm was developed by Chinese mathematicians. So they call the Chinese Postman tool. It's going to find out that how is the best way I travel every single street, yeah, given a certain community or given certain set of locations. That how do I cover every single street one time? Now, this thing, if you look, it is a quite classical. Usually, you'll be told to actually you to prove your computer's skill and then understanding about discrete math to develop something like that. But when it comes to actually we as an end user, we don't really care. We say, hey, I can put in it as a metric. I also can put in something like called graph. Of course, this is another representation, but we see this actually visualization is the same as the top. So there are different ways of defining it. But important thing is come to this super function. Say, hey, I don't really care how complicated this entire network is. I'm only interested in finding now how does it take for me to travel from one place to another? So I'll cover every single street one time. Yeah. So you give me an answer. So now in this case here, I say, hey, can we visualize it? Now, so I want to know, can you show me step by step? Yeah. How do I start my journey? Yeah, using this Chinese Postman actually algorithm. So it can show us step by step like this. Now, if the system can show step by step how it travel that, then we know, oh, I can actually animate it, I can visualize it, I can turn it into a video, I can so on and so forth. This is like static way of showing on screen. But if I want to turn into videos, no issue. I can actually become a model can run in my mobile phone. This is come to later part, how do we deploy it? But to let you know the simple function that makes our life so much easier, you only need to know what you want to achieve, what you want to solve. And most of the things here already automated for you. Now, for instance here, I'm using the same Chinese Postman algorithm. I'm going to solve a real-life problem. Now, if we say I have all the important city in Malaysia, now I'm going to use this thing to access to a Wolfram server. I'm glad that it's already up. I say, hey, this country is called Malaysia. Can you give me all the known city name, important city those small kampong, we don't care. About 200 over cities show up with all the names like alphabetical order, Alor Gajah, Alor Star, Ampan Jaya, Aitam. Of course, they all belong to different states, different places, because the system organized in alphabetical order. Now, if this organized alphabetical order, they say, hey, could you convert into GPS coordinate? I say, hey, I do want to know the names. I consider about position. Now, you see, all those are small built-in code, like entity value, also want a super function. The entity value, I say, hey, what do you want to know about this entity? I want to know about position. The system convert for us automatically, yeah, from city names into GPS coordinate. Of course, there are some other tools out there. We want to deal with geological analysis such as Google Map. Those things API could be available, but I do not have to make myself to be a programmer to understand what API is. I just use straight this Wolfram language. I say, hey, knowing this with all the GPS, can you use a Chinese postman, yeah, to immediately do analysis on Malaysian coordinate based on all the GPS I provided to you? Can you give it to me? I want to travel once to all the path. I only want to travel one time. If I want to fly a plane above all the cities available in Malaysia, how should I fly one place to another? He say, oh, this is how you start your tour. From this city number 1, then come city 3, 144, 31, 62, all the way go back to 1. Yeah. Then you complete one loop. Yeah. This using what? Using Chinese postman algorithm. Now, if I want to convert back to city name, I say, when you say index number 1, which city does it represent? The first city is suggested start. The start is Alau Gajah. So it start with Alau Gajah, Masjid Tanah, Sungai Udang, then all the way back to, again, Alau Gajah as a final destination and complete one loop. So now, if you want to visualize this thing with Malaysian map, right, you say, hey, knowing this is one thing, but I want to show it to my stakeholder. Does Wolfram language actually contain not just the numerical information about the important repository? Does it have something like even a global map, a city map, country map, that I can actually use it just like the way I use Google Map? Yes, fantastic. Everything is there because Wolfram is meant for you to do deployment. Now, this is a reason we have been actually advocating and pushing Wolfram, even though it's not open source. Yeah, like I say, Python is a good tool. Yeah, but it needs you sometimes, at least you have good understanding of programming. Start with Python. But Wolfram is more like functional coding. It's like heading to a lot automated, come to less coding environment. Immediately you get the result that you want. And you don't have to be programmer. You can stay as mathematicians, physicists. You can stay as yourself as engineers to get the result that you want. Just like we engineers use a lot of MATLAB, same thing. But compared to actually MATLAB, Wolfram actually is known to many of us is very supple in symbolic computation as well as numeric computation, and very good integrations with a lot of this user interface. And in terms of versatility, in how it blend with other languages, you can run Python coding inside Wolfram. You can call Python code package from outside into Wolfram. The interchangeability is very high these days. Now, for instance, here, I give an example here. This is last 2 examples. We can close this case and go into AI already. Now, you look at here, if I have these things available, right? Now, this thing here, if you say, hey, Peter, this is 9 pictures. I have this little taman, elite taman I have here. I have bungalow, I have actually city town hall, I have mosque, I have jaga, I have this thing, little house here available. But this thing here is not picture. So if you right click here, right, the system, if you change the other things, right, the system actually can turn to other shape, yeah, to show how this thing is, how they're related to one another. So you can change to some other actually shape you want. Like for instance, I say I turn to another different shape. This is another different shape. I want to turn to spiral. You can turn to spiral. It doesn't matter. Mathematically, it's still the same. It's just like this whole thing. I can make it to be like looking very nice looking. It's like how I put things in together. But now, having set this thing, I say, hey, could you use a find postman tool? I want to tell my security guard how you should actually patrol every single street. Where is the road you should patrol? Then I could put in some sensor. When you patrol there, you touch a sensor so I know you're there. But if you want to make it to be like in futures, right, when robot become cheaper and more prevalent, I'm not surprised. Like just now, like the video clip I showed to you about Chinese robot exposed. And how about you put inside a trained robot, yeah? No longer along with human being. Then the petroleum robot, right? Important thing is the batteries and the tear and wear machine. You want it to travel in very sufficient way, further certain path. So this thing will come handy. So you want to make sure every single area is covered. So this is how it's covered. And also if you say, hey, if this is area how it's covered, I want to know from one place it should travel another place. Could you find me a shortest tour? Now, this is another super function algorithm. You use this Hamiltonian approach. Yeah, Hamiltonian approach is another algorithm to help to see if I want to travel from location 1 to 34, how should I travel? Altogether involved, the total cost incurred is 38. Because from one place to another, you have different distance, different cost. So we say this is the cheapest cost. If you want to highlight it, this is show, oh, this is how you travel from place one another. Of course, if you want to actually animate the whole thing, you say, hey, Peter, you show this whole thing good, but I cannot see. Now, I quickly actually show one thing here. How actually I construct a code. If, for instance, I put in something called manipulate. Now, there are many actually very fantastic technology that built in. For instance, here, if I simply put in, say, hey, I want to put in the quick one. Let me show you the number of steps. Yeah, put a quick one here like this. Now, and also I want to turn this thing to be additional control here, and this tool here, this little control. Now it's done. Now, if I put this thing again, I want it to be something with little interface that I can deploy in my actually mobile phone or device. I can actually quickly try and drag this thing so the system can show me step by step how to travel from one place to another, from position number 1 to 34, step by step, yeah, in a visual manner, so I can actually see how I can get to the place I want in the shortest tour possible. So there are many ways we can play it. Now, the question is, you say, hey, Peter can do this thing so nice. Of course, you do a lot of coding. No. Like I say, the low coding approach this day, technology has changed so much. Now, if you say, hey, this is small taman, easy for you to say, maybe you also did a lot of things behind you didn't show to me. Now I'll show you what's happening behind. Now, if you have this little taman here, I'm showing you in Excel spreadsheet. Now, this is something, if you're not unfamiliar with script math, you know this is called adjacent matrix, adjacency matrix. Adjacency matrix is like how we define how each location connected, simply 1 and 0. Now, very simple, right? If you have 1,000 actually houses in certain taman, this is like ask them fill out formula. Who's your neighbor? Well, neighbor address number 1. Then if you're next to a certain neighbor in your 1, you're not related, not adjacent, next neighbor is 0. So this is how each neighbors are interconnected. So we just actually use a simple form to fill up, just like that, adjacency matrix. Then after that, each location, I say, hey, GPS coordinate, tell me how this actually in the XY coordinate, they are actually located. Very simple, XY coordinate only. Same thing here. How far are they from one place to another? Or are there certain costs incurred for one place to go another? For instance, certain path is quite narrow, certain path actually have a lot of stray dogs. I put in higher cost. I don't want to go there if possible. So with this actually information put inside here, I can simply actually import it. I say, hey, this is my Excel file spreadsheet. I import it accordingly. The system, what I have to do is I just update the backend Excel spreadsheet. It's done. The next thing I say, hey, this is the graphic I want to use. I can take anywhere graphic, live pictures from internet, anywhere I like. After I take it, I say, hey, the picture is imported. Now I'm going to use a picture I want. Immediately, voila, constructed 1,000 houses. Yeah, then you can start doing your analysis. So again, finding the shortest path, shortest tour, Hamiltonian path, Chinese postman algorithm. There are many, but today I'm not going to show all. Yeah. Like I say, just give you a way to have feeling. There are many real life issue that we can resolve. For instance, here, this is quite an old subway, actually, map in London. We know London has one of the world's most sophisticated, actually, transportation system. So in a similar way, I say, hey, this whole thing I constructed using Excel spreadsheet, adjacency matrix, then I put in some map, color, things like that. So I constructed this map very easy manner using Excel spreadsheet. Then I say, hey, if I want to go from one station to another, yeah, for instance, I want to go to Arsenal to Alperton, I say, I want to go from this path to that path, but I want to have less than 17 stops. Could you give me all possible paths from Arsenal to Alperton in less than 17 stops? Is that possible? Yeah. So the super function here called find path. I say, give me all the possible paths. So system here will immediately give me two possible paths. From Arsenal to Alperton, there are two possible paths to go there. Yeah. Let's say I say, hey, if I give you like 25 stops, would you be able to come up with more possibilities? The system analyze everything. Oh, it give me a whole lot more possibilities. Yeah, there are a lot more. So I put it 20. Yeah. There are also a whole lot more. I put in, let's say put it 18. Yeah, 18. Also, there are 4 possibilities. So all those things actually can help us do analysis. Now, when it comes to talk about graph theories, I share with you about network, and we cannot run away with tree. Tree means that the whole, when you look at network, usually the whole thing have interconnected with a complete loop, a cycle. Tree have not complete cycle, just like one location's connected with another location, we only one path only. That's all. Yeah, there is no interconnected. So these kind of things become important. For instance, I have a network here. Like, for instance, this is like, when it comes to investment analysis, right? Like this whole city here, this particular network in somewhere in the US, altogether about 10 cities. But I say, hey, I want to turn this network into a tree. That means that each city only interconnected with one connectivity only. I want to lay fiber optic. The fiber optic, in order to save cost, right? For instance, for this particular city, right? If I want to go for this place, I still sharing wrong screen, huh? Now, let me share back to screen. Okay, these are talking about. Just now, I'm still showing Excel spreadsheet. Let me come back here. I'm sorry about that. Just now, I did not show up the screen here. I thought I already showed you screen. Now, okay. Now, these are talking about. Yeah. This is the London subway. Yeah, London subway. Sorry, I thought I was sharing the screen. I stopped there. Now, this London subway. So I want to actually travel from Arsenal to Alperton. Yeah, 17 stops. Yeah, 17 stops. Yeah. So the system showed to me. Let me come back to here. Yeah. This is the London's subway stations. We constructed the same manner using Excel spreadsheet. So by adding in some of the location representation icon, things like that. Now after that, we say, hey, I want to use a super function called find path. Yeah, external buttons. Now it show me 2 possible paths. This first path, second path. Yeah, second path. Now, yeah, again, I say, hey, I wanted to have like 15 stops, no more than 15 stops. Say no. Minimum, let's see, 16 stops. Is that possible? No. The minimum actually stops from Arsenal to Alperton had to be like 17. So even 17, there are 2 possible actually routes to travel from Arsenal to Alperton. What about 18 stops? So they are getting more possibilities. 18 stops, there are 4 possibilities here. So it's coming out. So all those will be super functions. Now, we come to 3 here is like, we try to deploy actually fiber optics. So in this particular actually city in the US, so all the city in the US here, we say, okay, to travel for Maywood to this particular so-called Oak Brook, we have actually several ways of traveling. Yeah, if you look at here closely, right, the number of way you can travel from one way from this, you can go this way directly. Yeah, you can also go this way. Let me just try to switch it. Yeah, you can go this way and turn here. And you can go this way to turn here. So at least there are several ways of traveling. There at least are 3 ways from Maywood to travel or Blue. And each of them actually have particular name here, like 14, 10. These are involved like cost related, right? Involve like cost travel one place to another. So there are 3 possible routes. But if we can able to find a way to turn this thing into 3, 3 means that each location only interconnected by one edge or by one route. So then what will be the cheapest way to interconnect all the city here, especially when we want to come to major capital investment. So we're going to say, hey, I turn this entire graph into 3. Now, can you show to me each house city connected with the cheapest cost possible? Now, wrong. Okay, so I need to turn this thing graph one more time. Now, going fine. Okay, here. Now, it turned from the network into 3 right now. You can see that all the city only interconnected with one round or edge with the cost associated, and this is an optimized tree. Now, if you optimize tree, I say, hey, could you actually superimpose this thing so I can see it? How actually, based on the current and available route, which one should I upgrade accordingly in order to get the result for each city only interconnected with one route with cheapest investment? This is how it come out easily. Now, a lot of time that when we look at a network graph, we always talk about how we analyze social media lah, analyze infrastructure lah, analyze network lah, analyze hierarchical things lah. But also actually, not many people realize, yeah, in addition to this, actually by serious infrastructures analysis, operation management, in fact, you can actually analyze it, the assignment, yeah, of a task, assignment of roles using graph theory. For instance, here, this is something more that came out before the last election. I say, what if today these several parties come to form a so-called government persatuan? Yeah, somehow it came out this idea before actually it happened. And in this case, let's say UMNO, PKR, PAS, PPBM. They say they form this government persatuan. Yeah, we call UN. Yeah, this persatuan here we call UN here. We say, but they come to a political term. Say, hey, we all together we only have 3 minister and 3 timbalan minister, 3 TM, 6 minister posts. Make simple lah. Among these 4 parties, then they form a Kesatuan, this government, right? They try to have proper allocations of their assigned posts also. They only have 6 posts available, 3 minister, 3 timbalan minister. Yeah, they want to share. So again here, this is their term. I'm not saying I need to have 2. Yeah, PKR say I must have 2. PAS say I must have 1, max 1. But how many seats available? 3 minister posts, 3 timbalan, 6. But they are actually all together here. They say I must all together actually we don't have so many. Yeah, we don't. Let me see. Yeah, we only have 4. Correct. We have 6 posts available. And we all together here, they say they have come to agreement. 2 must come from here, 2 must come from this party, 1 from this party, 1 from this party, all together 6. Good, that's good. But the thing is, each of them have different actually representative. For instance, here, I'm not saying I'm going to send several more candidates. I'm not saying I'm going to send 3 candidates, R1, R2, and R3. PKR say I have 9 candidates, R4, R5, R6. PAS says I have R7, R8. PPVM say I have R9, R10. Yeah. So there are 10 candidates try to share this 6 minister posts. So in this case here, we can define the relationship like this. Yeah. For R1 here, they can either go 1 post of minister post, or R2, this guy is more qualified for timbalan. Yeah. R3, somehow the credential is better, is qualified for this minister post. And R4, okay, R4 coming from BKR, one could be for minister post, another for Timbalan, another for municipal post. And when coming to R7, yeah, coming from BAS, yeah, somehow let's say they agree lah, huh? One for Timbalan, one for minister. R9 was same thing, one for Timbalan, one for this minister post. Each out of R1, R10, they have different backgrounds and credential. Some are qualified for Timbalan, some are qualified for the minister post. So eventually, the final thing is we want to form a balanced cabinet, only 6. So now, if we put this thing into a graph, now the graph will look something like this. Yeah. So same thing here. Each of graph here, we can define what will be the actual capacity line. Final capacity, the cabinet, they can only altogether put in 6 person only. But we have 10 candidates. Each candidate have different actual qualifications. So now using this method, could we solve this thing? Now, in this case here, if I'm not sure if government have this tool, maybe they have this tool so that it can actually put this thing inside here to run. Let me see. Which one I miss out? Let me see. Okay, this thing is working fine. Let me see. Okay. Each capacity. Each capacity is here. They're missing something here. I accidentally deleted something just now. Okay, it doesn't matter. Just give me 1 minute. Let me see what I deleted. I accidentally deleted one line of code. Here we go. I need to define each of the capacity of the positions. So now here we go. Yeah, now nicely done. Now, in this case, we know this when relationship defined like this already in a graph, then I can start calculating. The maximum I can have 6 person actually from the 10 candidates fill up. Now then I can say, okay, based on this thing in the ideal situations, this particular assignment will actually satisfy everyone. So you could see here from UMNO, we have candidate number 3, candidate number 2 actually get assigned 1 to TM, 1 M. BKR, we have candidate number 6, we have candidate number 5. Also, each of them respectively go to M and TM. Same thing on BAS, one go to M, and PPBM, one go to TM. Eventually, we have 6 candidates actually go in. In ideal station, it works like that. So you could see actually this whole network graph actually plays very important part. So now, before we take the next 5 minutes break, I will quickly introduce to you what is happening out there about the AI. Just now we talked briefly about the industrial revolutions, what's happening. I'll quickly talk about what's happening in the AI world. Then we take a 3 minutes break. Then we'll dive into the Wolfram technologies with AI. how actually can help us to master AI's the technology in a very quick manner, even though we are not experts, yeah, in Python programming. I know AI have a lot of programming tools. Python is, of course, is one of the fundamentals actually platform people been using as open source. But what if you even want to go something even quicker, shortcut? How Wolfram can help us? But before that, I'll share with you now what will be actually the market happening right now. And when it comes to this altogether the AI development out there in the market. Now, you see here, this survey actually is what we took a few years ago. And among all those actually available market in all 28 industries, right? You're talking about this entire estimations, right? Just shortly from now to next year, right? The globally speaking on 28 industries, yeah, we're talking about investment in software only. It's about 126 billion. There's a lot of zero behind. Now, if you look at this 126 billions, right, it's talking about buying software only nearly about one third of Malaysian GDP already. But this is not all. This is not all. This survey was done even before generative AI becomes something that prevalent. If you look at another things, right? Another similar survey, this survey showed global AI by year 2025. This survey was done by Deloitte. Deloitte, actually, this survey was like say it was done before when generative AI become a topic. I believe it now. If you want to take into the generative AI like ChatGPT, Google Bard into pictures, the entire projection could be much higher. But even this survey was done by year 2021 by Deloitte, right? The global AI investment into hardware, talent developments, software, it was actually estimated to be like 6.4 trillion. 6.4 trillion, what kind of concept you're talking about 6.4 trillion? It's talking about 16 times entire Malaysia GDP. That means the entire income Malaysia, like, yeah, like 16 times. Yeah, for the global actually total revenue or expenditures in terms of AI technology. Like I say, we have this estimation haven't taken the part about the new developments of generative AI. Will be a lot more, I believe. Now, you look at these four basic things here. What if you are new to AI? Usually, people talk about traditional AI, and deep learning is going. I'm going to show to you. Yeah, what are these traditional AI? It's all about. It started in 1950s and with a basic algorithm like decision tree all the way to the 1980s. 1980s, we have so-called random forest, something more advanced. In 1990, we support vector machines, and all the way to year 2000, and like I say just now, the so-called reinforcement learning algorithm, and also deep learning can handle the unstructured data, so forth and so forth. And also together with large language model, how actually become a very important part in all aspects, like what Desmond showed to you yesterday. And even come number four, AGI, strong AI. Now, strong AI is people last year still say it could be something in a science fictions, but a lot of actually institution in out there in the world already invested in this so-called strong AI. Strong AI means that AI is capable not just one domain, but it's multiple domains. That means it's capable of driving car, cooking meal, and also doing homework for you. It is like super intelligence that it capable of multiple tasks. And is even during this is already a lot of if you go Google about strong AI, as early during pandemic time, even a neighboring country, Singapore, they already become a co-partner of one of research institution to study about strong AI. Let's see how it happened. And a comment by this guy, Li Kai-fu, is one of a prevalent scientist on this AI. And he says something I like very much. He say, we are not talking about AI 1.0. We're talking about AI 2.0. We are generating AI. And he says something. He said AI is not going to replace managers, but managers who use AI will replace those who don't. This actually make a lot of sense, and especially you look at the actual perspective of Amazon. Amazon been using recommendation engine, one of the very important commercialized AI technology ever since 20 years ago when it tried to sell books more effectively through Amazon online, and it will recommend actually books for you to buy based on your purchasing pattern and your background. And he was saying something. He was saying something. But this is what he said. He said there's no single group at Amazon. Say rather every team is responsible for finding ways to utilize AI and machine learning in their work. The way he said, like Jeff Bezos, the CEO of Amazon, as if saying that we don't have a single department for Excel spreadsheet. Everyone have to like master Excel spreadsheet. It's nonsense, of course. But if you were to tell people like 20 years ago, a lot of people still have no clue how to use Excel spreadsheet. They would thought, oh, this belongs to the IT guy. But now it's the same thing like what Jeff Bezos said 20 years ago about AI. This is what's happening. So now I will skip this part. Yeah, all the survey technology, this is the thing you know for sure. So I quickly now stop for 3 minutes, then quick break. Then for next 20 minutes or so before 5 o'clock, I will quickly give you a glance through that you feel amazed. Hey, I did not know actually AI technology could be so simple. I can use it also be confident. Yeah. A lot of people will be telling me like that. Yeah. Let's see what happens. I see you in 3 minutes. All right, welcome back. Thank you very much for staying put. And the last 20 minutes, I'll show you something very exciting. And it's all everyone's talking about this day. Yeah. I'm going to share with you is my perspective of traditional AI and deep learning. And traditional AI, like machine learning and deep learning, is going to stay and will continue to stay. And because it's something like fundamental. Of course, generative AI is something like it put in the AI tools in everyone hands. Like government just announced they're going to come out with the free AI courses, yeah, for everyone to sign up with. I'm not sure what they are going to teach. Right? I'm not sure what they're going to share the layman person. Maybe I think most probably they're going to share about generative AI. But for R&D people and also people in the business, right? Traditional AI is still the fundamental that we need to actually get familiar with, and we sort of exploit it for our advantage. So now, if you look at here, this one on the example here is it very fundamental thing is the traditional AI automatically help us do prediction or help us do categorization automatically. Now, if you look at the prediction, it's like having a history of X and Y. How could you come out a fitted curve mathematically so that you can base on an equation to do prediction in terms of X for Y? Yeah. So Mathematica is a regression model. But when things actually progress, it becomes much more complex. This so-called X no longer X. It could be like a graphic, yeah, like this, different graphic. So if you want to turn this thing in graphic, right, this is unstructured data. How could the system actually understand instead of the numerical X to keep us a prediction in terms of Y, like this one 40.2, 8.9. But there's a lot of automation happen in background. To make this something like this to happen actually is quite difficult technically. But in the past 5 years, things change a lot. Like Wolfram actually doing a lot of pre-processing. Yeah, for a complicated things like this, right? To base on the input as using input we call features. The feature is actually graphical things. How to actually turn into like one line of code that we can actually use it for our machine learning or for our AI application. Like in this case here, this particular object called myPredict, now it becomes something like an object we can use. If we throw in, it's a become function we can use. We throw in these 3 parameters, different pictures or different images, which never exists before in the history here. The system actually can come up with prediction what the associated Y value is. Yeah. So based on the patterns it learns, these are unstructured data, it learns automatically. Wolfram perform a lot of pre-processing, yeah, to make this thing become one-line code. Then we can use it as an AI object. So if we go into something that's simpler, right? If I have XY coordinate, this XY coordinate can represent 2 features, feature X, feature Y, yeah? And you give me an output here, possible 4 outcomes, red, blue, green, and do we have purple here? No, 3 possible outcomes, red, green, blue only, 3 outcomes. So now, the output here will actually 3 categories. So this is another actually important use of traditional AI. Could it actually automatically help us do classifications and help us differentiate based on the features available, what category does it belong to? So now, in this case, based on historical data provided, we're asking the system here, hey, can you learn from histories? So system right now doing a lot of pre-processing, learn from history. Oh, the output here, there are 3 possible colors. And the input here, there are 2 features. Based on here, I'll provide the system here 2 parameters here. This first parameter here is, of course, XY features. Now, I will tell system, can you tell me what will be the outcome will be? So system automatically look at these 2 values here. It say, oh, I think it should be green and dark blue. So I say, how sure are you? Then I'm asking the system, I say, okay, tell me the probabilities that involve this. Yeah, I say, give me probabilities. So system tell me, oh, I think if this green color, right, is 77% of chance is correct. Similarly, this dark blue, the second one, 77.3% should be dark blue. So some other colors also got probabilities, but much lower. So system has higher confidence. The first actually features here, the first set of parameters here will actually result in green color. Second set result in dark blue color. So if we move on this, based on this concept, right, almost in this automated machine learning approach, right, you can get result very quickly. Now, for instance here, if I left hand side here, this feature is like different set of color, I get it from internet, from Google. Then the right hand side, I simply say, oh, by using human judgment, I can easily judge it's day or night. Yeah. So I say, please learn from my judgment. So I'm training this little baby to understand from pictures in order to differentiate day or night. Now, if this like back forward 5 or 10 years ago, to make this thing work is very complicated. You need to write like few pages of codes to make this work. But this whole thing, Wolfram had pre-processed all those actually so-called features and output for us. So we can throw in all kind of objects, not necessarily numerical data. You can throw in a lot of categorical data, A, B, C, string, color, even some other media file. The system will do a lot of pre-processing without we have to be the expert in machine learning. Of course, some of the fundamentals concept we still have to master so that you can be able to explain to the end user, even to convene the cell. So now the models now is done. This object called my model, it becomes a function. So I can throw in 3 new pictures from Klang. Yeah, this is my hometown. I say, can you tell me day or night? Yeah. Of course, to process actually use machine learning algorithm to handle this kind of data. Sometimes might not be efficient because if you have too many actually images, right, your memory will quickly run out. Yeah. So, and there are also certain limitation machine learning when trying to handle actually images or media related input and output. But I'll talk about later in deep learning. Yeah. This is what deep learning is good at. So, but now you could see for normal actually machine learning model, you can come out actually quite easily. Yeah. Now, for instance, I want to predict cancer patients. Now, if we look at here, to do prediction cancer, right? Like say, when we started doing project like that, right? 7, 8 years ago, wow, this is quite difficult, a lot of coding. Yeah. But now you don't even have to concern much. In the past training, in past 2 or 3 years, a lot of trainees who attended our class, they feel amazed. Say, hey, eventually I realized I do not have to be like programmers to handle this. I can actually, as long as I understand the fundamentals concept of machine learning, I can quite confidently follow this entire workflow to get a result that I want. For instance, here, this particular Excel spreadsheet, they have like so many columns. Column 1, let me see, I need to share our screen. Now open up this Excel spreadsheet. It's on our screen. Now, this Excel spreadsheet is raw data on people who are diagnosed in a historical diagnosis, whether they are suffering from breast cancer. So they have this so many columns here available. You will see here they have column all the way to 30. So they have like 30 columns of reading coming from mammogram, just looking at the size of the tumor, color of tumors, things like that, and to give a diagnosis whether this is benign or this is cancerous. So the output diagnosis will be M or N. So if you look at here, this historical data, 30 column of reading, and altogether here, the data set is not big. If you scroll down, it's like all the way to approximately 500 over patients only. But it's quite sufficient already. So with this approach, right, now we no longer actually have to spend a lot of time to understand the traditional approach. Only a few steps only. I import from an Excel spreadsheet. I say, hey, I want to import from breast cancer Excel spreadsheet. That's it. It's importing 500 records, 20 columns. Now, after that, I say, hey, let's do a little transformation because after all, you need to transform it from an Excel spreadsheet and only a few lines of code, the system able to understand. Yeah. For instance, here, if I click on this, showing this information here is, these are 30 columns of reading of this medical record here, 30 columns here. Yeah. And the result here is M. Yeah. This is cancerous. M cancerous. Cancerous. B benign. So we have altogether about 500 over records get imported with their features and output. So now with this thing available already, the next thing is say, okay, this Excel spreadsheet is successfully imported and transformed. We only have to actually do some actually testing and training. So we'll keep 80% record for training and 20% later to test our accuracy. Because when we come out with model, right, the system say, oh, this is AI model. I come out, I say, hey, how accurate you are. So I say, okay, I'll keep 20% on my patient record. I'll test it. Hey, how accurate you are compared to the actual one. Do you make a correct prediction or not? That's the reason we keep 20% from the data set. Now, then come to the important part is you see only one super function called classify. That's it. That's it only. Yeah. You don't need to go through a lot of pre-processing. If you read through the traditional textbook or AI, it's good for you to understand the fundamental, but you read through, oh, there's so many things you need to do as a groundwork. But now, this is automated approach, right? The system will do everything for you, even scanning through all the available algorithms and select one of the reasonably good algorithms for you to run. That means that you can force the system to choose some algorithms you're familiar with, or you let the system choose for you. Yeah, one of the reasonably good algorithm for you. The system choose. Let's see what the algorithm system choose for us. It say, oh, the algorithm it choose for us, right? Is logistic regressions. Yeah. Say, okay, I say, oh, fine. I don't even know what logistic regression, assuming I did not even know. So I say, fine. I just want to find out how accurate it is. Now, I run this small test of accuracy. The system tell me, oh, even though with the short period of time, 1 minute, right, I can get accuracy as high as like 98%. Yeah, this is something a whopping approach, like 98% accuracy. And if I further scroll down, I will see that this is something called confusion map. Confusion map is to tell us visually how good we are making a prediction. So the statistic or chances of making right prediction is very high. This tool is very high. We are making correct prediction between cancers and non-cancers. The system differentiate based on 20% data that we have set aside for testing, and they achieve it nearly like altogether 98% accuracy. So you say, hey, this code is so simple. I didn't even do much. Now I already get the result that I want. So now, if you go to the next thing is, you say, hey, in this case, can I use the same approach to do on other actually similar cases? Yes, by all means. Now, if I use this model, I have specimen, right? This patient who did the mammogram, right? This is specimen given to me. I say, can you tell me whether this patient is suffering from cancers? Now, you say, no, 98% is benign. So quite okay. And this patient is safe. Yeah. So give me a probability. So the next thing is, if I do the same thing and say, hey, I have one file actually given by a bank. It had 10,000 records. These 10,000 records keep track of credit histories of customer, where they are from, the gender or the age and saving and the transaction pattern, so and so forth. Could you actually, based on this historical 10,000 data, tell me which are good customer, which are bad customer? Good customer, I want to keep it as much as we can, give them more offer, give them more discount. Bad customer say, hey, never mind lah. Yeah. Will the system automatically give me actually flagging, which is good, which actually will work more my attention? Something like a recommendation engine by Amazon. Based on the past pattern, what books am I interested in? This is another things. The product is human. Which humans should I pay more attention to based on the past behavior? So same thing, I perform a data transformation. Then I say after that, I'm going to take 80% for training, 20% for testing. Then after that, I say I'm going to train my model. Now, again, the system will quickly actually analyze for me. Yeah. Running through this 10,000 records, yeah, scanning through different algorithms and make a decision which algorithm is reasonably good for me. Of course, I can make more study to choose so-called the best amount of good. Yeah, I can do that. But if I say, I just want to quickly get an answer, yeah, with very high level of confidence, I'm actually doing the right thing. Yeah. Now, this is a very good approach. The system actually calculating so-called the 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 cost function and give me the loss value real time. After that, I'm going to test more. I say, hey, how accurate you are, yeah, based on all these customer, then my accuracy now is quite satisfactory. Yeah, I can get as high as nearly like 85%. So the system can immediately quickly tell me that this how well it can detect actually the good customer and the bad customer. Yeah. So the system actually will tell, oh, this is how among all the customer I have here, how well I can able to separate them, the good and the bad. Yeah. So this is like as simple as a few minutes a job. Yeah. Compared to something like in the past, in this whole project, maybe it can easily cost you like 10,000, 20,000, even 50,000 if you make it something that more dealing with more complicated infrastructures, data set, and cleaning things like that. But now this whole thing is at fingertips. Now, of course, if you want to use the model, yeah, I say, hey, I had this customer coming from Spain and France. Which are good customer, which are bad customer? Immediately based on past historical value, and now I key the new customer background. They will tell me, oh, these two customer are actually a quite good customer, 86%. This 90% quite a good one. So it's good that we actually welcome them as VIP. So now, if you're talking about this traditional AI, say, hey, Peter, you talk about deep learning. Does it mean deep learning? Now, deep learning is another type of AI algorithm that is able to handle unstructured data. Unstructured data means that you do not tell what's the customer credits, gender, uh, uh, how much saving they have. You do not have this information. You simply throw in raw data. The system will be able to automatically make sense out of the entire profile. For instance, you take a picture of the persons, whether the system can recognize a male or female or how old the person is, how can it tell? Yeah, if you give it enough data set in terms of images between the age and the gender, the system will learn from there. Yeah. So this technique is one of the algorithms of machine learning we call deep learning. It's very efficient to handle actually this kind of unstructured data. It also will allow the system to do learning along the way with a minimum cost. Yeah, for machine learning, right, you need to train and retrain. Every time you have new set data, you need to retrain. For deep learning, no need. You can train the sub data along the way. That means that, yeah, 1 million data trained. Same thing like how come Google can actually automatically categorize our photo? Yeah, yeah, train millions and millions data. So you learn every day. Every day maybe have another 1 million of new data for the train, get more accurate. It does not have retrain the past few millions data. It just train another new set data every day. So you get improved along the way. So deep learning is capable of doing this. Also, deep learning can able to distribute out the memory. For instance, now if you want to train any unstructured data, it's very memory consuming. If your computer has like, let's say 16 gigabits, you look up all the high definition images for the system to do machine learning, very soon you run out of memory. But using deep learning, right, you can take in data portion by portion by controlling the usage of memory. The system will learn along the way. Yeah. And also you can use a GPU to make it faster. GPU like maybe have 32 or 64 GPU core. You can actually do distributed computation compared using your CPU, only have 8 cores, yeah. And this whole thing, not just faster, but more economical. Now, for instance, I use this example here. I have actually few example here to show quickly so that you have get idea in the last 5 minutes. Oh, Peter, 5 minutes you can show deep learning, definitely, because now technology becomes so simple. Now, I have actually 4 folder here. This 4 folder here, I put here one is COVID folder, but I keep a data set very small. Like this COVID chest X-ray, normal chest X-ray. Yeah. You will see on the screen, this is all the X-ray people taken from one of the hospital in China. Yeah. People who suffer from COVID, people who actually get the lungs get destroyed by COVID. Yeah. This data set, I truncate it, make it a bit smaller size, so the whole training will be faster. Now, another one is this one we get it from a website. For instance, this is quite common in production. If you want to actually make your machines smart enough to able to see, hey, I have this fabric. These are all good one. Yeah, only except some wrinkle. Yeah, defect free. And how about some of the fabric got stains? Now, if we say, hey, human eyes also can tell, of course lah. But if today you go and deal with like 10 or 1,000 of these samples with human eyes, right? Humans will become less consistent. We get tired, we get oversight, and then we make mistake. Now, if we train machine to do this, right, either 10,000 or 1,000,000 makes no difference to machines. So same thing here. I start very simple here. There are three types of fish. Can I ask the system actually learn from differentiating this is guppy fish and this is swordtail, yeah, swordtail. And of course, we look at here, we know lah. But I put little images here. Could the system actually, even with little images here, with simple example here, it give me a quick result? Yeah, this is the zebra fish. Now, same thing here. I give fourth example. The fourth example here is I have now folder. I'm keeping the images is like tiles. These tiles here, original data set about 10,000 images, but I do not want to do this. I put in 100. Tiles, this is normal tiles, yeah, but have different actually texture lah. But if a human being, of course, you can tell, oh, this is simple lah, huh? But for machine actually, for it to learn, actually not the simple. But that's why I put in something more obvious lah. This is like a crack or very obvious crack, right? So you can tell difference. Now, the actual project we did a few already. So some projects like involve like also 10 or 100,000 images. Then we have to train use few hours and to show that whenever I take photo, the system will automatically use handphone take photo of the whatever sample, the system automatically tell, oh, this is defect or not defect, and what type of defect they are. So the concept is the same. So now, if we go back to here, this simple model in this particular one, let me just turn off some of my other apps so to save some memory. Now, this case here, I only have to first thing, for instance, here I say, hey, you see only 4 steps only. 4 steps only. Of course, deep learning is not something simple. Yeah. But again, the coding these days becomes so much easier. And of course, you need to understand some fundamental things of deep learning in order to achieve something that we are showing. But I would let you know is this day a lot of things make so simple. Now, in this case, I only had to point to where my this folder is. My folder, we keep it here called UM 2024, and we go into this particular folder called fishes. I call fishes, right? I say, okay, this is folders I'm interested in. Now, the system know you will look into this particular directory. The next thing is I say, now let's start doing training. And I want the system train 10 times. I have certain control. I say, hey, repeat 10 times. I want to run on GPU. I want to use a batch size 6. There are some of so-called hyperparameters we control. Yeah, in machine learning or deep learning, there are certain technical terms we use, like hyperparameters. Hyperparameter means that certain thing you can play with in order to control the accuracies of the outcome. The rest we leave it to machines to actually work out the internal calculations. So systems running right now is reading in the images. When the first time it runs, right, it triggers my GPU automatically. My computer I'm showing right now is normal laptop. My laptop is already 4 years old. I bought it before pandemic. Yeah, a simple GPU by NVIDIA for gaming purpose, but it is running very well. Even with this machine learning and deep learning, the speed by turning on this GPU, I no need to do any setting. Right, just the system auto detect it and run the rest. And the speed is 10 times more than I'm running on CPU. So it finished running. The next thing is I say, hey, after that, I want to know what's accuracy like. Yeah? Accuracy. Say, tell me how will you detect my fish lah. So then I will decide whether I can use or not. Now, this is warping. Yeah. Of course, my sample size is very small to really tell for sure whether this is accurate or not. It's 100%. The system can detect guppy fish correctly, zebra fish correctly. And now, if we say, oh, if this thing can detect correctly, can I put into use to see how I can use this model? Yes, you can use it. I can export this model, I can use it. Now, to show you, like, for instance, before this training class started, I already pre-run the model and I save this all model into a file. This already pre-trained. COVID, fabric, fish towel. Now, each of the training, right? If you have 10,000 or 100,000 of these, all those images, right? It might take you like sometimes hours or days to do training. Yeah, even a super NVIDIA GPU card, right? If images high definition, you're dealing with 10 of millions images, it might take like few days, even weeks to finish training. Yeah. Now, after the training, right, you want to save a file somewhere. So then you want to use it. The whole training file was small. It's only contain the internal parameters after you go into a training. Internal parameter is very small file. So, but in order to get a small file, you need to go through many hours training. So same thing here. After you done it, then I say I don't need to go through training anymore. I just need to open up the correct actually train model. So I say, hey, I open up train model. I say where my train model is. My train model is here. I already pre-train it and save it. I may train for many hours. So the model I'm interested in is this one, model save. I say now I want to look at the model called fish model. Now open up fish model. Now the model is now ready for me to do inferencing. Inferencing means I start using it as an object. Now, this particular importing of parameters when it's done, I can start putting in this image here, fish. I say, can you tell me what fish is this? What will be the probability? Now, here, I run it. The system will tell me, oh, based on what you have trained previously, right? 67% a chance this will be like swordtail. Yeah. It's not 100% sure because my images are not sufficient, quite small. So, but what about this? Now, if you want a system to understand this graphic, now, of course, like I said, this is not strong AI. Strong AI means that you have one system can understand everything. Yeah. Almost like Google have trained like billions of pictures that it can tell more different categories. Now, but I train based on different type of products. So this is like traditional deep learning. So based on certain categories. So each time I need to actually go to retrieve the correct safe train model that I already had. In this case here, I'm interested on tau. Say, what is the tau models that I saved? Okay, the model I saved is tau, so I choose tau. Now, it imported tau model. Once it's ready, imported tau model, the next thing I say, ask, this picture, is it good one or bad one? You say, the result, 98%, this detected actually correct. So lastly, there are a few other pictures like this one is like, quite obvious, looks like the lungs actually get damaged. But I want to be sure. Okay, same thing. I use the same method. I go to the model that I have previously trained. Then I retrieve the model name called COVID. Yeah. Now the model is now open lock, so I can start using this function. Now to look at this particular X-ray. So the X-ray here tell me, oh, this guy 99.6% is sick. So hopefully today that with this quick overview, these 2 days, right, I get inspired about how technology this day, especially make available in Malaya for past 6-7 years, available to everyone. There are many training videos we already uploaded to our website, and also there are many resources available offered by Wolfram. I'm very sure, depending what you are training, interested in R&D or learning, what you're interested in learning or what you're interested in lecturing, you'll find this actually technology added important tools for your actually productivity. But I say, hey, Peter, how do we do this? Yeah. Consult us anytime, free. Yeah. You can approach us, WhatsApp to us, email to us. Hey, Peter, and that's how do we deal with this? How can I make my life better in teaching, learning, or research? You are always welcome. Yeah, because we are here. We have been with the community UN for many years. We're happy to see you grow. That's why we are here. Give you special 2 sessions online. Not detail is enough, but hopefully it's comprehensive enough how to deal with the current new development out there in market. So about a certificate and the other things that what is coming up next and what is other new resources available, I pass the time Desmond so he will do some explanation.
Okay, thank you, Peter, and congratulations to all of you that stay until this last session of today and then complete the whole 2 days uh brief training. I can say brief because we are only touching the surface. There will be for more in-depth, you can go through all the documentation, also like free video that Peter say, and also the sections that we already record in the YouTube. You can also review it if you want. And the certificate for the today is already the link already put on the chat room, so you can just click and to request your own certificate. And for that's it for today, and for future events, you can also like our Facebook page. We will always put on the new coming training or webinar or any other events on the Facebook for you to join in. There will be sometimes will be a paid training, sometimes will be some free event as well. Okay, that's it for today, and I will let you go now. If you have any questions, feel free to email to us or reach us through WhatsApp as well. I just type in our email address. So you are good to go now. Thank you so much and see you again. Bye bye. I will paste the material for the workshop as requested by one of our participants in the chat room. I'll put the link on so that you can download it for today's section and also from yesterday's section as well. Just give me some minutes to pull out the details. quick announcement. Sorry about that. I think the e-certificate have been some problems that some of you are not able to get the certificate with your name on. No worry about that. We have received your details. Once we fix that, we will email to all of you again for all the certificate. Sorry about that.